Hey, Yusuf. How are you, my friend? Hope you're doing well. How you doing? Switch over. There we go. Nice. There we go. Hey, Steph. How are you? Are you doing good? Thanks for the follow there. Jade, hello. How's it going? Hey, how's everybody doing here today? By the way, I shaved a little bit from the last stream there, Steph, so I know I look a little noticeably different. I do, everybody says when I shave, like 10, 15 years off my face. Yeah, I'm doing really good, Steph. I'm doing wonderful. It's been a good go. Actually, I had a wonderful weekend, nice and relaxing. I hope you and have a very good week so far. How about your week? Although it's been cold and stuff like that here in the U.S., but you know what? Been having a nice, fun old time. I hope you are having a nice, wonderful, fun old time over there in the UK. Looks great. Thank you. Thank you very much. I'm trying, shave a little bit. It grows back in about, no, I don't know, a week or two. Leave it for a month and rinse and repeat the process. It's always pretty fun. Yeah, affiliates actually pretty nice to have, Steph. I hope your first few streams have been going really well. I'm in a really good mood today. I'm in a really good mood. It's actually been a very good week. Cheska, hello, hello, hello. How are you? How was your week? It's been 1 week since we had last had class, Cheska. So feels like a lifetime ago, but hey. What do you do on your streams there, Steph, by the way? I'm just kind of curious. I gotta follow you now. Actually, let me do that right now. Why not? You have your own stuff. I think I should follow you. It's kind of important there, you know? There you go. There you are. I dropped you a follow there, Steph. Absolutely 100%. A few games from chatting? Guitar! Oh, you sing as well. Wonderful. Well, much better than my pipes, I'm not gonna lie. Fainer shaved chips. Hey, it does exist, okay? I promise you, it does exist. It's not the super cleanest of cuts because, well, it's kind of grown in from last week. So, no, Steph, absolutely. You deserve a follow as well. I think you bring a really positive vibe to the community. It's a lot of great, wonderful, positive voices, and I know you bring a lot of contributions, not only to the women's team, but just your attitude in general. I can totally tell that the positive commitment is there, and I really respect that. I like that very much. So definitely, hands off to you, Steph, for being a wonderful person, and being a wonderful, positive contributor to the community as well. Thank you so much. I also sing. You also sing as well, Yusuf. Respect, my friend. Respect. Anybody that can sing, I automatically give them instant respect for that because I can't sing worth a darn. You put me in front of a karaoke place, no problem. I'll sing for you all day. So I agree. Singing is fun. You know, I've have my own version of singing stories. Sam, you can't wait for a Jim solo. Let me tell you, when I was in a bar in Japan a long time ago, I did my solo there doing a YMCA chant. Imagine having a whole bar basically singing with you at the same time. That's right, Steph. That's right, Steph. I totally agree with that. Totally agree with that. I got another one for you. I always follow one motto here in this channel, and that is this: less stress, less mess. That's how we run in this channel here. It's a very, very simple. We try and follow simple ideas, simple things. So not too hard to implement, and I hope that everybody is less than stressed out here. Rip Ellis, thank you for the follow. I just saw that. Oh my gosh, why didn't that pop up? Okay, that was kind of weird. But Ellis, thank you for the follow. Ellis, you are an amazing. Yeah, look, Steph, I've learned a lot in the past many many years. Um, but yeah, you know, I don't let the drama take hold of me. I just try and keep it as simple and easy as possible. That's what we do. It's as simple as that. I think we've all been through those nonsensical things before, so if we keep it less stress and less mess, we'll be in good shape. I think that's definitely true. You can't sing for the life of you. Really sing in the car will no one. You know what, BMZ? There's nothing wrong with that. I sing in the shower. I can sing in my car. I could sing to you on stream. I just don't want to have your ears bleed. But if you get me into a karaoke place, it doesn't have to be like at a bar karaoke. You could do one of those private booth karaoke's. I will gladly sing my heart out. I will do my rendition of, you know, Michael Jackson's "Beat It." I happen to be pretty famous at that when I was working overseas. That was one song. Now, when we do karaoke, it's got to be in person, though. That's the one thing. It's got to be in person, because then I just throw caution to the wind. If I sing on stream, I'm going to bother my neighbors, and then they'll hate me forever. Did I have fun playing on Valheim yesterday? Yes, it's so addictive, Jade. Oh my gosh, that game is super addictive. By the time I knew it, I had played 5 hours, and I was just like, I just wanted to keep going, but I'm like, yeah, I gotta go to bed. It's really fun playing with James and Milky. Today, no Valheim, though James is playing right now, by the way, if you didn't look on Discord there, Jade. So he's been playing since noontime your time, so he's totally into it. I don't even know if he thinks Rachel exists anymore. It's Valheim first. Megan, good morning to you. Good morning. How was your week? Look at this wonderful people, man. Holy moly. Gotta love it. It's always on that. Too true, too true. I like to take a break sometimes when I'm playing games, so. AJ with the raid. Thank you so much, my friend. Thank you so much, AJ. I hope you're doing well today, my friend. I hope you're doing wonderful today. It's a lovely, lovely day here. I've had 2 tests this week for biology. Oh, man. Well, you only got 1 test due on Sunday for this class, so I think you'll be okay. At least you could focus on bio and then do my test, you know, take the practice tests and do all that stuff closer to the end of the week. So you should be all right. We're in good shape here. Got AJ, my dude, how are you? Look at these. Look look at these amazing people in the chat. Got Steph and Jade and Sam and BMZ and Yusuf and Megan and Cheska. I can't believe you guys are here for a Mathematics 102 class. Oh man, you guys are legendary. Thank you so much. Super kind people deserve super shoutouts. Absolutely 100%. Did you try the test there already, Cheska? I hope you did. Can I? Yeah, of course, BMZ. I have had it open since last Wednesday. So from last Wednesday until Sunday, you could take it anywhere in between. At the last moment that you can basically submit it is going to be on Sunday at 11:59 p.m. BMZ, giving you any amount of time, and you get multiple attempts too. So, Kristen, how are you? Are we doing okay? I hope we're doing well. All right, good. I'm glad you're working on the practice test. It's going to be exactly like our test here, exactly the same type of test, just with different numbers. So now you'll get a good idea about the formatting and whatnot. We got some important things to work on here today. I think we are ready to go. Idanos, my friend, how are you doing today? How's the weather out in Israel? I hope it's doing really well, my friend. We have a test. If you were officially part of my course, then you would. Absolutely. Actually, let me... Hey, watch the language there, Adanos. I'm gonna have to I'll time you out for like 10 seconds here. Ah, I didn't mean to do that. Oh, I meant to time out for 10 seconds, not that. There. Adanos, come on back. I'm so sorry. My bad. Ah. Well, I'll have to figure that out at some point. All right. Sorry, Adanos, I didn't mean to do that. I meant to do something else. That's my fault. How do I unban people? Never know how to unban. Hey, Kristen, can you unban Idanos? I apologize about that. Okay, thank you. My moderators have more knowledge than I do, and I'm a moderator myself on hashtag. Oh my gosh. Sorry. You swore there, Idanos. You gotta watch the language there, my dude. Apologies, my friend. You know I wouldn't do you dirty like that on purpose. I just gotta, yeah. I wouldn't do you dirty like that, Adonis. I like you too much. It's okay. I like to keep this PG. So, all right. Let's do this, ladies and gentlemen. Ladies and gentlemen, with a T. All right. You move over here. Alrighty. Pause that for a second. All right. All right, let's do it. Let's do it, ladies and gentlemen. We're getting ready. Let's do this. Okay. Let's do some intro here. Hey, Wade, how's it going, my friend? Okay, let's get started today. Welcome back to Wednesday. Only time we're meeting this week, so it's end of the week time here today. So I hope everybody had a wonderful week here. We didn't meet on Monday because of President's Day, but today we're going to get right into talking about some of the new material. But actually, before we do that here today, there is something that I do need to talk about here specifically to all of you here in class. So I do want to talk about that here right away. One of the questions that we did here last time is we talked about again putting together a box plot, and there was something I forgot to tell you about box plots for this first class. I did it for my second class, but for some reason, when I look back over, I was like, oh man, I forgot to do it in the first class here. So I'm going to go ahead and showcase that off here first and foremost, so that way you can use it as a reference to help you for your test that, again, remember, is due on Sunday, okay, at 11:59. All right, so if you haven't started the test yet, this will be extremely helpful for you. Really dry in here. That will be available on Wednesday. That'll be available on Sunday. Not available on Sunday. Due on Sunday. What am I doing with my life? All right, so let's go ahead and here. Okay, so what I'm going to showcase here is I'm going to showcase the calculator here. So if you have your calculator out, you might want to take out the calculator here. We're going to go ahead and show off the calculator. We're going to see exactly how the calculator works with box plot information. Now the calculator can technically show the box plot here, but I do want to kind of showcase here once again on how to look at how to find that box plot information, such as the minimum or such as Q1, going to be the median, Q3, and the high number here. Again, that 5-number summary that we talked about here last time. So I'm gonna let's go ahead and show this off here. So I hit the stat key here. I go over to edit. All right. And I can enter in whatever numbers I want here into list number 1. So I randomly made a list of numbers here. Again, these can be any numbers here. These will be especially proved to be useful when you're trying out some of the test problems here. You don't have to put these in order, by the way. I put these in order for the sake of ease, for what came out of my mind, but you don't have to put these in order if you don't want to. Okay. So once you go ahead and enter in those numbers, that is very loud. Oh, so once you figured out those numbers there, go ahead and put that in. Now what you want to do next is, once you have the numbers in, hit second in mode to quit out to the main screen here. Then hit the stat key here. We're going to go over to calc, and we're going to go over to one var stats. Ellis with the raid. Ellis, my friend, how are you? I hope you're doing well. Thank you for the follow, by the way, Ellis. Thank you very much. It's super kind of you to do so. So we go over to calc here. We go to one var stats. And as you can see here in the submenu, we have list. Again, we want to call upon list 1. If you're not sure about list number 1, you hit second and 1 to show up list 1. You're good? Wonderful, my friend. How's the weather out there, Ellis? I hope you're doing well. Going to go down to calculate, and then this is what should appear here on the screen. It's good? Good. Yeah, it's getting a little warmer out here, Ellis. It's pretty cold though right now, so been very cold the past week. That Arctic wind is no bueno. All right, so here on the screen, I want you to take a look at several things out here. All right, first of all, you see the minimum value here. The minimum value here happened to be 3. That's the lowest value in my data set, for example. Then we have Q1. Again, we talked about that from before. And then if you scroll down here, you can see the median, Q3, and the maximum values. So it gives a 5-number summary here of the data set specifically. Again, let the calculator kind of do it for you for more complicated data sets, things that you could find on that. There you go. Maths on VAR. I wish you could teach referees this. Well, remember, VAR is built on mathematics, so those goals that are allowed or disallowed are based on millimeter discussions. I could tell you that. That can be good or bad depending on where you sit. Most people sit on the side of VAR as not being the very most friendly thing in the whole wide world, but it can call into change about the new offside rule. So, a new offside rule would be fairly helpful to give a little bit more leeway. Of course, Dylan. All right, so here's how you can find a 5-number summary. All right, are there any questions about finding this 5-number summary? And basically, you could take this information and make your box plot from there. It shouldn't be too hard to do. Again, it's pretty easy once you figure out your 5-number summary here. But then this is a nice little shortcut way to actually find that out. So Any questions? Any questions, anyone? Again, type no in the chat if you have no questions, and then I'll move on. But I just want to be sure that. Thanks, Dylan. I appreciate that. Nope. Right? Nope. Nope. All right. Thanks, Yusuf. Appreciate it, my friend. All right. Good stuff. Wonderful. All right. Thanks, Dylan. All right. So now that you got a good idea about how to use the calculator here, at least for those small questions, it should be relatively easy to tackle some of those problems that have pretty large data sets that you'll have to enter in. You don't have to do everything by hand necessarily for some of the things. The other things you will have to do that here by hand. Yeah, so office hours here, specifically Feiner, is going to be after 2 o'clock. So 2 o'clock here, technically after my next class. So after 1:45. So if you want to stick around here to the stream after my second class, my second 102 class, Feiner, I will be holding office hours there. So that way I can answer your questions. Okay. All right. Cool, man. Any other questions before we move forward? Nah. All right. That's fine. Okay. Okay, moving on. All right. Okay, so today, let's look over what we're doing here today. All right, so today, we're going to continue moving forward here with our good friend Probability here in Chapter 5. Okay, Chapter 5 is where it's at. We're going to finish up a couple things here with Chapter 5. All right, so Chapter 5 here will be, Yusuf want me to hydrate. Oh, missing my drink. Okay, hang on, let me go get my drink. Right back. Right. Put this back on. All right. Today's drink is going to be very different than any other drink I've had on this stream. Be a very unusual drink. Today, I have it's supposed to be a refreshing drink for the heat, but obviously it's but I have a salty lychee. It's juicy lychee with Okinawa sea salt, and I've never had this before. This is a rather unusual combination. Um, you thought you saw me shopping at the Jewel I work at the other day? I don't know which Jewel you work at, but I haven't been in Jewel in a while. Maybe a lookalike? Ooh, that is tasty. Ooh, that's really good. Oh, I was a little skeptical. I bought this for like $3, but I was like, ooh, oh, the one in Schaumburg. There's a couple one in you mean the one on the corner of Wise and are you talking the one on Wise and Roselle, the flagship store, Megan? Because if it was, then I mean I haven't been there in a while, but that's my local Jewel. Okay, it's okay. You can see me here now. Okay. Schaumburg and Bear. Oh yeah, I don't live close to that location. Oh, I know what that one is. I've been there once, though. All right, we're on 6. Okay, so let's go over number 6 here. We're going to be able to finish up section 5.1 and section 5.2 here today. Let's go ahead and get going here, ladies and gentlemen. All right, so last time we talked about how to find we talked about properties of probabilities here. We talked about what the notation for probability here is. That was the P of something here. We talked about sample spaces there at the end of class. Today we're going to put this together here. We're going to look at some examples here in section 5.1. We're also going to look at some stuff here in section 5.2. All right, so let's take a look here at number 6. It says, how do we compute probabilities of equally likely outcomes? So equally likely outcomes, it says if an experiment has n equally likely outcomes, and if the number of ways that an event A can occur is m, right, then P of A is equal to the number of ways A can occur divided by the number of possible outcomes. All right. So this is kind of what we talked about here last time, but let's discuss, again, just to give you a nice refresher from last week, exactly what did we kind of discuss here? Well, this is like the example here was again rolling a again rolling a 5 on a 6-sided die, okay, for example. So there's an equally likely outcome here for every number on the die. This is one thing that we did talk about here last time. All right, every single number has an equal chance of being selected once you roll the die, and it's like a 1 out of 6 chance for every number. But as we talked about here, the word of warning here, the big thing that we talked about here is we have to really watch out for the wording of the event in question. The wording here in this chapter here, I will reiterate here, is going to be incredibly important. Okay, very, very important here. Okay, now why is that? Again, let's talk about why that is. Let's look at a couple of examples here using our same 6-sided die example, and then we'll see exactly how that works. So again, a nice reiteration here from last week, but very important to set the tone here for a lot of what we're going to be talking about here in this chapter. Okay. All right, let's take a gander here. All right. Okay, so looking at this 6-sided die here, we're just going to assume a 6-sided die. So looking at this 6-sided die here, let's say if I roll, say the probability of getting a 3 or 5. What's the probability of getting a 3 or 5? The probability of getting 3 or 5. What's that going to be? Probability of 3 or 5. Why don't you guys tell me here? Okay. So 2 out of 6 or 1/3. Okay. Okay. Good. Good. Right. So to get 3 or 5 here, we could either roll a 3 or we can roll a 5. All right. So there's 2 numbers on the die that satisfy this condition out of 6 possibilities. All right. And so exactly right. We can just change that to 1/3. There we go. Simple enough. All right. No problem. 100% agree. Okay. Let's try it this way. About the probability of 1 in 4. So probability of 1 in 4. All right. Very good. All right. So you saw right through it. That's excellent. Okay. Really good to see that. The answer here is indeed 0. That's right. Trying to get you with the wording again. You you caught me, Wade. That's absolutely right. And that's exactly what I would like you to look at. Right? So the key word here is or. When we say or, It's either this or that can happen. It could be one situation, it could be the other situation, it could be both. Obviously, in this case, can't be both because it's a six-sided die. But we have and as well. Okay, but and means that 1 and 4 have to simultaneously appear on the six-sided die. So again, hence why it's 0 and not 2 out of 6, unlike the last problem. Very nicely done, everybody. I'm really liking what I'm seeing so far. All right, excellent job. All right, so far so good. All right, let's go ahead and take a look here at some other problems, though, and let's see exactly what we're working with. So now you get a good idea about how the wording goes. That's perfectly fine. Let's look at some other example problems. Throw the text here. Go. Bam. All right. All right. So let's take a good look here at. Let's take a good look here at which one I want to look at. Oh yeah, let's look at that one. Okay. So let's look at number 30 here. So let's look at number 30 here. It says planting tulips. So number 30 says a bag of 100 tulip bulbs purchased from a nursery contains 40 red tulip bulbs, 35 yellow tulip bulbs, and 25 purple tulip bulbs. Letter A. What is the probability that a randomly selected tulip bulb is red? Okay, so let's do that here. All right, so let's do, again, problem 30A. Just going to go. Does anybody have an answer here for problem 30A? What's the probability that a randomly selected tulip bulb is red? And want to be sure about this one. Yeah, I would like a decimal answer. All right, so I would like a decimal answer for this. There we go. That should make it a bit better. 0.4. Okay. That's 0.4. All right. Excellent. 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 Very good. I agree. All of these answers are correct. So 0.4 is correct here. Again, for us to get that here, I'm going to go halvesies here. Just a moment. Okay, so for us to get that here, again, you just take 40 out of 100 here. Okay, we get 0.4 as our answer. So 40. So put that here. Paint tool. Paint tool. So again, we have the probability of red. So 40 out of 100. 4.4. Good. All right, how about letter B? Probability that a randomly selected tulip is purple. Right? Randomly selected tulip is purple. .25. Okay, good. Right. All right, very, very good. That's correct. All right. Easy peasy, lemon squeezy, right? 25 out of 100 to select that purple bulb. All right. So our 25 purple tulip bulbs in the bag. So there we go. We got it. Easy, easy. All right. All right. Questions so far about that? Hopefully that isn't too bad. Pretty straightforward, at least. I'm going to do one more example here from this section. Okay, That one. All right, let's look at one more here. All right. Now I'm gonna ask a couple of different types of questions here. Maybe one question or two. So, college survey. In a national survey conducted by the Centers for Disease Control to determine college students' health risk behaviors, college students are asked, how often do you wear a seatbelt when riding in a car driven by someone else? The frequencies appear in the following table. All right, so here's the frequency here. All right. Now, what I'm going to do is I'm going to ask a simple question here from 35. So, from 35, what is the probability of uh, most of the time wearing a seatbelt? So what is the probability of most of the time based on what you see here? So if I randomly select a person here, what's the probability that I will select a person that answered most of the time here to this particular survey question? What do you think will need to happen here? Again, we will get a decimal answer here in this instance. Let's go ahead and see exactly how that's going to work out. Hopefully not too shabby. Yeah. Hmm. Well, let's at least answer this question here. How many people took the survey? 0.26. Okay, I see some good answers here. All right, how many people took the survey? So let's at least answer that here. Because if we're going to take it out of 4,776, okay, that's right. So all you have to do here to get that 4776 right is to add up the frequencies here together, which I hope you did. So I think most of you saw that just fine, which is very, very good. I agree with that. Okay, so that's where we got the 4776 from. All right, and how many people answered most of the time? 1257, right. So according to our chart here, it was 1257. And then we just take that there. And Feiner had it all the way out, so 2632. So 0.2632 here. We're going to take it out to 4 decimal places here in this case. That's okay. You good, BMZ. I know what you meant. It's all good. You've done well, my son. Okay. And there we go. We got it. Okay, remember, 4 decimal places here, by the way, for your answers. Like I said, most answers here from pretty much here on out are going to be 4 decimal places in some capacity. So I'm just going to let you know about that now, so you'll know exactly what to expect later on. Okay. Questions about that? Questions? Nope. Okay. All right. So hopefully this will be easy. Let's do one more here from this table. Let's do one more. One more. Really quick. So about the probability of never or rarely. You guys give me the answer here for the never or rarely. Probability of never or rarely wearing your seatbelt here. I always wear my seatbelt, but that's me. When I was a kid, though, I never did. But that was the 80s. So 80s and 90s. I ain't gonna lie. Okay, that's correct. Good, good, good. All right, so you add these two together here, 125 plus 324. Put that together there. You got 449 over 4776. That's a 9. And then that's correct. We got 0.0940. There we go. Nice job. Hey, Aiken, how you doing, my friend? Doing well. I watched a portion of your match there, Aiken, getting 5 red cards on FIFA, and and your play there, your play style. I'll tell you. Um, that's okay. It happens. I'll get upset from time to time. That's okay. You're okay. All right. Good job. That is correct. 0.0940. All right. Good stuff there. All right. That's a. Let's see here. Okay. All right. Let's talk about. Oh, snap! That would kind of surprise me. Shoot. I was like dying. Hi guys. Hey Jesse. Thank you for the raid. I hope you're doing well. You and Sydney. Really appreciate it. Liverpool champions. Thank you for the follow. Appreciate you. Hey guys. I hope you're doing well. I hope you are doing well. Thank you so much. Jesse's a legitimately really nice fellow. Really, really good guy. Wonderful guy. Yeah, the raids keep on coming today. It's gonna be like that. Steven Stokes, hello. Okay, let's talk about the empirical method. Okay, this is actually something I did talk about this weekend. Hey, Jesse. Nah, man, you do well for yourself as well. Thank you so much. It's very kind of you to say. Um, let's talk about the empirical method. If we talk about the empirical method, if I could spell the empirical method right on this. Okay. The empirical method usually involves a large amount of trials in an experiment. All right. Now, what does this exactly mean? I put an example here. It's if you have flipping a coin to determine the probability of getting heads is more accurate the more flips you make. So think about it this way. I flip a coin, right? Okay, if I flip a coin and I say I want to get heads or tails. Now, what are the odds of me getting heads in a single flip? Now, the odds of me getting heads in a single flip is 1 out of 2, right? I should have a 50% chance of getting a heads, and I should have 50% chance of getting tails. That's exactly what should happen every time I flip a coin. Now, when you try things out 10 times, let's say you flip a coin 10 times, right? You flip a coin 10 times, you could get 7 heads and 3 tails, which would mean you have a 70-30 parity, right? But if you do it 10,000 times, you will notice that the actual odds will actually tend to be 50-50. So that's correct, Aiken. That's right. If you do it a million times, you will get you'll get closer to that 50-50 split, which is exactly what it should end out to be, as opposed to say a 70-30 split if you do it just say 10 times. Okay? So having a small sample size. So the important thing that we need to discuss here about this and what the kind of the overreach for this is basically is this. And what's the key? The key is that you need a sufficiently large enough sample size to make proper conclusions. Sometimes it's, for example, the same thing as imagine flipping a coin a million times. Well, fortunately we now have computer simulations to do that for us. Think about all those predictive analysis that they do for like sports. Okay, if you talk about sports and you say, what's the expected winning, how many games is a team going to win with the current team makeup? They do that in baseball all the time. Is like, what's the expected wins for a particular team? And they may run the simulation a million times or more, and then they have an average of how many wins that team got from the lowest to the very highest, and then basically you can then go ahead and project that particular team for that particular season. Okay, so obviously anything can happen within any sports season, but at least it gives you a good ballpark estimate about where the team should probably rank if they play to their expectations. So that doesn't mean to overachieve or underachieve, that just means on average. All right, so very, very good to have empirical data here. So that way, again, you'll make more solid conclusions at the end of the day. This is very important, like if it's like saying again, if one person tells you, blah 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 is true, that doesn't mean anything. Okay. Oh yeah, absolutely. Sorry, Aaron. I will certainly do that. Here you are. So again, if one person tells you blah 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 is true, that doesn't mean anything. I first need to see, of course, the research behind it, but also I'm going to need a lot more. I'm going to need a lot more backup than just one person. I'm going to need not only the data behind it, but I'm going to need a lot more qualifications from other people as well. Maybe I'll need 1,000 people to kind of qualify that particular opinion. Maybe I need 10,000 people to qualify that particular opinion. And I need to look at it from an unbiased perspective as well. So sometimes that can be the tough part there, because sometimes we only want to hear what we want to hear. So got to be careful about that. All right. Let's talk about the next part here. Aaron, oh, I'm sorry, Aaron. My apologies. Did you get everything there, Aaron? Let me know once you got that there. Yeah, a survey with 4 people, like I said, we did talk about that earlier in chapter 1. A survey with 4 people tells you absolutely nothing. Like, oh, you got it? Okay, cool, Aaron. Yeah, a survey with 4 people tells you absolutely nothing. All right, it basically tells you the people who typically do the like a survey, they're going to be very heavily opinionated. So typically you get extreme opinions for like, hey, customer service surveys. Did you do really? I really hate your guts. Or I really like your stuff. The best feedback is going to be the ones that are kind of in between the extreme opinions. So, constructive feedback that can help you improve. That's typically the ones that you really want to take into account. So, but if you get consistently the same complaints, then you do have to take that into consideration as well. That's one thing you have to take to the bank. Ooh, this drink is so good. Oh my gosh. Please give me more. All right. All right. Number 8. What is a compound event? Okay. So let's talk about compound events. Compound events are basically 2 or more events that can occur, and they could be events A and events B. Hey, young toast, how are you, my friend? I hope you're doing well. So we could have event A and event B. Now, there are 2 types of compound events here, and this is where we need to be a little bit careful about our definitions. Let's talk about what this means from not only a definition perspective here. Young, thank you for the follow, my friend. Um, let's talk about it from a picture perspective. I think that'll be better. So let's talk about number 9 here. Okay. Number 9 says, what does mutually exclusive / disjoint mean? Okay. Now, a mutually exclusive event is 2 or more events that have no outcomes in common. Let's put it in a picture perspective to make it even easier to understand. I think sometimes when we look at these guys, you're like, it's kind of confusing when you just kind of put it into words. I'm like, yeah, that's fair. So let's say we have a sample space. We'll call this big block here the sample space, okay? Here's our sample space S. All our possible outcomes are in this sample space. Fair enough. All right, let's say we have event A. Let's call this circle event A. All right, so whatever event A is, there it is. There you go. And let's say we have event B. We'll call this circle event B. I think you guys have seen this before. maybe back in other classes, but we're going to use this here as well. This is especially useful for, say, biology. You talk about biology Venn diagrams, but in any case, this is basically what mutually exclusive disjoint mean. Essentially, A and B will be totally separated. All right, they are two separate things. They have nothing to do with each other at the end of the day. So nothing that they have in common. They don't overlap at any point in time. And this is essentially what this picture looks like from a simple perspective, okay, when everything is mutually exclusive. Now, this makes things significantly easier, as you can see right below. Because what we have to do here is, if we're going to figure out probabilities of either mutually exclusive events or not mutually exclusive events, then we need to actually compute those probabilities in two different ways. Let's show off how we can go ahead and do both of those. So let's look at the bottom of this page here at number 10. And we're going to go ahead and do some examples here, and then we'll answer question 11 to go along with that. So we're getting there. All right, so question 10 says, what is the general addition rule? The general addition rule says if they're mutually exclusive. All right, it's super simple. If you're taking the probability of A or B, then all you have to do is take the probability of A plus the probability of B, because they don't have anything to do with each other. Again, it's like rolling a 1 and rolling a 3 on a 6-sided die. They're mutually exclusive events, right? Rolling a 1 has nothing to do with rolling a 3 on a 6-sided die. So who cares? Okay? They both have the same events here, and they're both 1 out of 6 chances. And all you have to do is add 1 out of 6 plus 1 out of 6. You get 2 out of 6. Easy enough. All right, so just like we talked about here earlier on in class, same deal, we're good to go. If they're not mutually exclusive, you're a bit confused here. If I have two separate coin flips, they're mutually exclusive, but you can't just add the 50% of landing the tails. No. Essentially what you're doing is, you have to basically take a look at, they are mutually exclusive events. This is true. So you're just basically taking 1, 1, 1, 1, 1, 1, 1, 1. That's basically what you're doing there. But remember, you have to divide that by how many trials you took. So how many tails and how many heads you got. It basically, by the law of empirical data there, kitchen sink, you'll actually see that it's 50-50 if you flip it like 10,000 times or things like that. Yeah, this is if we don't have two separate coin. We have using the same coin, correct? If that makes sense. So we're not getting 1 here necessarily. Remember, there could be different sample spaces for flipping the coin 2 times, by the way, just to let you know. So if you take a look at a coin here, you could have 2 heads. Let's say you did it twice. You have 2 heads. You can have a head and a tail. You can have a tail and a head. And you can have a tail and a tail. So you actually have 4 things in your sample space there, kitchen sink, if you want to look at your sample space, depending on how many times you flip that coin. Because those are the samples, that's the sample space for 2 separate coin flips. So the probability of your event has to be dependent on, the probability of your event is dependent on what happens in the first flip and what happens in the second flip. So you basically put those together, and then you'll be able to get out an actual probability. We'll actually look at that here a little bit later. I think, yeah, we'll actually look at that a little later. Any other questions before we move on? You could get as many times as you get heads and tails. Just depends on what the coin flips. So again, you are either going to get a heads or a tails on a coin flip, right? So it just depends. You're just trolling with me, I know, but I gotta answer honestly. It's just random. It's all random at the end of the day. No. Okay. All right. Now, what about not mutually exclusive? What about not mutually exclusive? If you add the probability of the first flip, well, the thing is, kitchen sink, what you're assuming is that the sample space stays the same. So remember that the sample space here is different for every flip of the coin. Okay? So flipping a coin here doesn't necessarily, so again, flipping a coin here, it's dependent on, because every single part of the sample space will change after every flip of the coin. So I just want to point that out here. The sample space changes on every flip of the coin. So you could say, again, the sample space here will change. You have A, you have B here. Okay, this could be flip number 1, this could be flip number 2, but this sample space will change because you flip twice. So this sample space, if I just had 1, I would have a 1 out of 2 chance. That part is true. Okay, but now this sample space changes because of the second flip, so now I actually have 4 things in my sample space. So B is going to be like, okay, I rolled, I flipped tails. Okay, well, I have chances there. In fact, in that case, we actually use the general multiplication rule as opposed to the general addition rule. So, which we will talk about here. There is a rule for that, by the way. And one other thing here, kitchen sink. Remember, that's A or B, not A and B. So be very careful about your wording here, kitchen sink. Okay? All right. Okay, let's look at the probability of A or B if they're not mutually exclusive. Okay, if they're not mutually exclusive here, then this is going to be equal to the probability of A plus the probability of B minus the probability of A and B. Okay, so the probability of A plus the probability of B minus the probability of A and B is if they're not mutually exclusive. Okay, so let's look at some problems here. Let's look at examples here. So that way, hopefully this will satisfy a kitchen sink. All right, let's look at some more problems. Okay. Yeah, 50 times isn't enough though, Aiken. You need to flip it like 10,000 times. So if you really want to get a good sense of a good 50-50 split, 10,000 times is probably a good minimum to go with. So you could build a program out of that. I mean, to be fair. All right. Let's take a good look here at some problems and we'll see exactly how this will work out. All right. So let's look at 29. All right. So let's look at 29 here. So in an effort to reduce the number of hospital-acquired conditions, such as infections resulting from hospital stay, Medicare officials score hospitals on a 10-point scale, with the lower score representing a better patient track record. The federal government plans to reduce Medicare payments to those hospitals with the worst scores. The following data represents the scores received by Illinois hospitals. Okay, so here are the scores here. Again, the lower the score here, the better. So let's take a good look here at this. Okay, I'm gonna make this big. All right, first we want the probability that a randomly selected hospital in Illinois has a score between 5 and 5.9. So Let's go ahead and let me go back to that half screen again. And so between 5 and 5.9 here, let's do that right now. Let's start off with something basic and work our way up. Probably between 5 and 5.9. Yeah, there you go, Kitchen. Nah, you're not being dumb, man. It's a fair question, Kitchen. That's a fair question. I can see where the confusion can lie, to be fair. To be fair. A and B are outcomes of the... Yeah, okay. Correct. To be fair, Kitchen, it's okay to be confused about that. That's why I wanted to clear that up with you. What's the probability we get between 5 and 5.9 according to this chart here? Let's go with 4 decimal places here. Ladies and gentlemen, let's go ahead and do it. .184. Okay. So I think 0.184 is 0. So let's do this here. We have 23. Okay, 0.1840. Okay. I wasn't sure, but I trusted you guys, so fine. So it's 23 out of 125. No, I like questions like that. I think it's good to answer questions like that when you get confused. That's what I'm here to help you with. So I don't disagree. I would, if there's anything you get confused about, I'm here to help. That's what I'm here to do. So I'm not here to tell you, oh my gosh, I'm just gonna ignore you. So all right, so 0.184 is correct. 0.184 is correct. That's correct. Okay, let's take a look at another one here. I'm going to kind of skip over just a little bit. One of the questions here we can't do just yet, so I'm going to skip over that one here. Okay, let's determine the probability of here, less than 9. So the probability of less than 9. So what is the probability of less than 9? .96. Okay, that's correct. All right. So let's answer this question here really quickly. How did we get 0.96? I want to know the process about how you got 0.96. This is the more important part here. Reason why I mentioned that here is because we want to talk about, I want to see what your thought process is about how you got 0.96. By the way, I don't disagree with that. Okay. We did 1 minus that. All right. You added all the numbers from 1 to 8.9. Okay. All right. So you did it 2 ways. Okay. We have 2 ways that I see here. All the frequencies, yes. Totally understand what you meant there, Megan. 100%. So you add up all the frequencies here, and I'm pretty sure you got, what you added up with the frequencies. So the number of 1 to 8.9 here over the total frequency. Meant to say total here. My bad. All right, so here we got 120 out of 125. And so indeed we got 0.96. Now I agree with that. All right. Did the same. Okay, that's fair. That's fair. Now again, both methods, so Kitchen's method and your method, are 2 very solid methods here. Okay. So let's talk about that other method that Kitchen presented here, because this does have a formalization that goes with it as well. Sometimes it may be easier for us to find probabilities in the other way. So maybe you look at this question, and this is the reason why I like this question so much, because there are two ways to approach this problem to still get the same result. Okay, so you guys added up all these numbers here together. Now you probably used a calculator and whatnot, but you probably look at it and says, that did take me a while to add up all the numbers and then divide by 125 to get 0.96. Kind of like how I have it up here on the paint tool, and that's perfectly fair. All right, no question about it, 100% true. All right, but thing is that maybe there's a faster way to do it. But we're going to need to know how to do it the faster way. So let's bring that up here right now. That's the last question here on this handout. And that is, we use what we call complements. So question 11 there on the handout says, what does complement mean and what is the rule of complement? Well, this is just basically saying complement in math language just means the word not. So I could look at it as saying, I could look at it this way. I could say, okay, the notation here, by the way, is a with the c here as an exponent. Let me make that a bit bigger. There you are. All right. And if we want to take the probability of the complement here, we take 1 minus the probability of a. Okay, 1 minus the probability of just whatever a is. So if I looked at it this way, like Kitchen did, okay, let's look at it this way. So the other way we can look at this is that we could say, okay, well, I want to figure out what the probability of less than 9 is. Well, how about if I look at this way? The probability of less than 9 underneath the rule of complements, well, what's the opposite of less than 9? Well, the opposite of less than 9 is, of course, 9 or more. Okay, so I could say, well, 1 minus the probability of 9 or more. Okay, so then if I looked back at my chart here, let's go back to our little chart here. If I look back at our chart, well, 9 or more only has a frequency of 5. So we would do 1 minus 5 over 125. And then either way here, you do that on the calculator. And in this case here, we get the same result here of 0.96. So as you can see here, there's two ways to actually approach this problem here. Again, sometimes complements are going to be significantly easier for us to do given the type of probability that we may need to work with. Okay, so we now have an option on the table here for us to figure out probabilities from a different perspective, which is very, very powerful, especially when it comes to specific wording that could make it pretty difficult or sometimes impossible if we don't look at it from the other point of view. Just because of how many times we would have to add together, it could just be really, really difficult. So we obviously want to avoid that as much as possible. So sometimes taking the easy way out, at least from the other side, may prove to be worth it at the end of the day. I also want you to take a look at one more thing here that I've put up here on the paint tool here. Take a look at one more thing here. Let's talk about opposites here for just a moment. Okay. Okay, so what you need to do here is take a look here. I have 5 over, this is 5 over 125, by the way. So if you do 1 minus parentheses 5 over 125, make sure the 5 over 125 there, Feiner, is in parentheses. Yeah, make sure that's in parentheses there, so that way the calculator's doing 5 over 125 first and then taking 1 minus that. Oh, okay. Oh, you missed the 1 there. Oh, that would be a problem. I was going to say, that's fair. Okay, that's fair. Okay. Now I want you to take a look at, it should, Kitchen, but it's good practice to tell the calculator. So the one thing is that, yes, it should there in that circumstance, Kitchen. But I will say this, Kitchen, the one thing that I try and do is if you're going to use the calculator is very particular in how it wants things entered. So good practice is basically put parentheses around what you want to declare so the calculator does do proper order of operations. Okay, the calculator is not always super smart about how it does certain things because of order operations. So if you want to distinguish one number from the other, it's good practice to put parentheses around those numbers. Even if it doesn't do anything, at least it's good practice there. Yeah, BIDMAS is what they use over in Europe. PEMDAS is what we use here in the US. Something I learned this semester. So they're both the same thing. Okay. Now, I want you to specifically look at the wording here. I'm going to circle the wording here, by the way, in this instance. The wording I want to look at here, E stands for exponents, kitchen sink, exponents, is that we have less than, and the opposite of less than is that number or more. So we have, again, I'll put number or more, because it could literally be any number. It could be any number here. In this case, it's a 9, so it's 9 or more. But I want you to take a look here at we have less than, and the opposite of that is that number or more. This will be something that is very important as we'll look on from this chapter forward. So that's something that you'll see pop up from time to time, and something that we do need to be aware of. So just be careful about that. That's something that we'll need to be a little bit aware of. All right, good stuff. Let's do another question here. All right. All right. Okay, so this one here actually uses something that we will talk about here later, but I think at least this is important now. Let's do it now. All right. So let's look at number 40. Okay, so number 40 gives us this table here. Okay, so this is what we call a contingency table. All right, and we could do probabilities with this particular contingency table. In this case here, it talks about the employment status of married couples within a particular school. So there we can see how many children under 18 that that the parents have. So husband and wife, okay, or both spouses. Again, we can see one or two or more, or zero, and they give the totals and all that jazz. All right, let's take a look here at some of the probabilities behind this, and let's see what we're working with. All right. Okay. So, what is the probability that for a married couple selected at random, both spouses work? So, the probability that both spouses work. All right. Again, would like a decimal for this, but how do we set this up here? Uh, probability that both work. Probability that both work. According to our table right below my face. Probability that they both work. How many people? How many of them work? How many of them both work? Taking a look at this table here. What's the total here that both work according to the table? 0.6759. Okay, tell me how we set that up there. Okay, how do we set that up? So I want to see. I can agree with these answers here. I just need to know how we got there. That's fine. That's what we're here to cover. 1149 out of 1700. That's correct. Okay, so there's 1149 that are in the both category. If we add up that row, out of the 1,700 people that were surveyed here. Okay, right. So again, the setup here is incredibly important. So that's why we're kind of focusing on that here. I agree with the final answer. Sometimes in this case, the process is a little bit more important. So, 5, my fault. There we are. Perfect. All right, that's what you meant to do. Fair enough. All right, good. All right. Let's try the next one here. Actually, let me try C. That one's actually pretty. What is the probability that for a married couple selected at random, the couple has 2 or more children and under the age of 18 and both spouses work? So we have 2 plus and both work. All right. So probability of 2 plus children and both work. 370 out of 1,700. Okay. All right. So let's see if that's correct there. All right. So taking a look here, remember, the key word here is the word and, right? It has to be both 2 plus and both, right? Correct. So we need 2 plus, so it has to be in this column here, and both. So that is correct. 370 people surveyed had both those conditions set aside to find this probability out of the 1,700 that we pulled here for this particular example. And so correctly stated here, if we go ahead and put that together, 0.2176 is correct. All right, good stuff. All right, let's look at another one here. Okay. Let's do letter D here. The probability that for a married couple selected at random, the couple has no children or only the husband works, so 0 or husband. So the probability of 0 or the husband. Okay, so let's set this up here appropriately. Okay, now we have to be a little bit careful about this one here specifically. Okay, so we want to find out the probability of 0, okay, plus the probability of husband. Give him a little time, kitchen sink, it's fine. But remember, based on what we talked about here before, we have to subtract by the probability of A and B. Now, I want to talk about this here for just a second. The reason why we want to subtract by the probability of A and B here is why do we want to do this here? Note is that the probability of A and B takes away the double counting. Okay, so I do want to point that out here in this particular case. Oh, what happened? What happened there? There we go. That was kind of weird. All right. So the probability of A and B takes away the double counting. This is actually very important. Okay. So I want to point out here, we're going to subtract the probability of 0 and the husband. Okay, so as kitchen sink has put up here, correctly so, we take a look at the probability of 0. Now, if we take a look at the column here of 0, so let's follow along here. The column here of 0 is 788. 788 people had 0 kids under age of 18. Fine. Then we have the probability of the husband. Probability of husband here, which is this row, is 425. So plus 425. Now I want you to take a look at what happened when we added those two together here. So here we added 0 kids in this first column, and we added the husband only row here, which where we got the 425. Notice that this 172 here, this was counted once when we first did the 788, and then that 172 was counted again when we actually did the 425. So this is where the double counting comes in. We actually counted 172 2 times. So we need to get rid of one of those countings. So that's why we're trying to subtract by 172 here, and then divide that all by 1700. So the 172 is the 0 and husband here. Since we already counted it twice, that's essentially what we come up with. So here we got 788 plus 425 minus 172. So here we get 1041 over 1700. And if we do that out, we get 0.6124. That's correct. Okay. Okay. Are there any questions? 0.6124 is correct. Yes. Are there any questions about that particular problem? I want you to see exactly how we broke that down piece by piece into getting those numbers that we're looking for here in order to find our probability. How did we get 172? Now, 172 came from both 0 and the husband. So remember, it's the word and here that's actually really important. Remember, it's 0 and husband, okay? So, Fainer, how many people were underneath the category of 0 and the husband, right? So 0 and the husband, if you take a look here, that's the 172 here. So as I said here, that's already been counted 2 times when we found the probabilities of the first 2. So we need to take away one of those countings. So that's why we're subtracting by 172 there. You'll notice on certain questions that you may, if you're doing it wrong, you'll get a probability of above a 1. And you know that you did it wrong if you get above 100% probability. So if that happens on certain problems, it can. If that happens, then go back and make sure that you subtracted off the correct amount. So that way you do get a probability between 0 and 1. Okay? Any questions about that, anyone? Any questions? We're going to do one more here, by the way. Would it be unusual to select a married couple random for which only the wife works? Okay. Okay. So let's look at the last one here, letter E. Would it be unusual to select a married couple for which only the wife works? So the probability of the wife here, we take 126 out of 1700. Okay. So in this case here, would this be unusual? Yes, it would be, you say? Okay. Let's find out. What's this probability here? What's 126 over 1700? Careful about that. Sorry, kitchen sink. Apologies. I have that automated in Nightbot. I don't know what you put there, but you must have put something on the blacklist. I put some words on the blacklist there. I have to go back and check those on Nightbot. Nightbot did that automatically. Thinks you were spamming. Yeah. Sorry about that. That's not on you, kitchen sink. You're fine. I'll just I think if you put too much there, I think it sets the flag off. But I can always increase that. So that's not your fault. There. So can anybody tell me there? 0.0741. Correct. All right, so is this unusual? Yes or no? Is unusual under 50%? No. Unusual. Well, actually, what is unusual? Under what percentage? 0.0741 is correct. But unusual means under what percentage? Under 1%? I don't think so. Not under 1%. When it's less than 5%, that's correct. So let's give ourselves a reminder here. Remember that unusual here means under 5%. So under 0.05 or 5%. All right, so that's our standard definition here. So would it be, so that's correct, okay? So 7.4188, so it would not be unusual. That's correct. So not unusual, since we're using that metric. Correct. All right, very good. That's right. All right, nice job, everybody. Questions about today? I hope today was pretty easy. So the probability that anyone will survive Attack on Titan Season 4 is about the same probability of you liking Gabby. Wade. Yes, that's correct, kitchen sink. 0.05 is pretty much the common standard, and it is based on the significant threshold. Nobody likes Gabby, Wade. Nobody. Everybody should know that by now. If you're gonna watch season 4, yes. If you're gonna watch season 4, you should know that's true. Thank you, Kitchen Sink, for the follow. Appreciate you, buddy. Team Falco. There you go, Team Falco. Respect. All right. Okay, so that's where we're going to end off here for today. We've got a little bit extra time here. All right, next time we're going to do a little bit of group work here in section 5.3. All right, so we're going to do section 5.3 here for next time. all right, which is going to be on Monday. All right, but yeah, again, remember that the test here is due on Sunday at the end of the week, okay? Due on Sunday, 11:59 p.m. Be sure to hand that in by then, okay, everybody? All right, everybody. I hope you have a wonderful weekend, everybody. All right, I'm going to be here for my next class in about 10 minutes, all right? So I'll be sticking around here for just a little bit, but in the meantime, you guys have yourself a wonderful weekend. Get that test done, all right? Take care of yourselves, everybody. I love you all. You all are wonderful people. Keep the positive vibes flowing. Remember to stay safe, stay healthy, and most importantly, everybody, for this first class here, stay sane. All right? Have yourselves a great weekend, and we will see you on Monday. All right. Take care, everybody. Have a good one. We'll be back here in just a moment. Alrighty. Okay. Oh, you're leaving me already? Oh. Oh. Take care, FD. Fair enough, my friend. Family first, of course. Yeah, of course. Yeah, you can use the inspire if you want. I don't mind. It's overkill, but yeah, you can use in the inspire. Absolutely, my friend. Hey, Ashley, how we doing today? We doing good? I hope we're doing well. Hopefully you great. That's good to hear. I'm happy to see that. I've had a really good day already. It's been already a very productive Very productive day. Only getting more productive. I hope you're ready for this. I mean, we're only meeting today for this week, but you know, again, you've been cleaning all morning. That is good. That is good. Cleaning can take a lot out of you, but you feel better about it at the end of the day. Banana, hello, hello, hello. I hope you had a wonderful weekend, Banana. Hope today, JD, hello. How are you? Athena, hello. Buenos dias to you too. Yo, mucho gusto. Today. I do like today very much. Look at all these wonderful people that come out here. You finished drawing a kitty? Wonderful. You know, I do need a real kitty in my life. Would love to have a cat. Love to. Cats are amazing. Callum. Excellent drawings of horses. Oh no. Oh no, last semester I've been ruined by that picture of a horse. Absolutely ruined. Oh man. Much love to you, Callum. You want to foster a cat? Yeah, you know, fostering animals, it's fostering animals, I tell you. The Picasso really just. Yeah, absolutely. If you can't come to that one, come to this one, Athena. You're always welcome. You know how it rolls? We do it back to back, and we get the same things accomplished, and we forge ahead. And that's what we do. Get it done. Get it done well. Wait, you want to see this horse? No, you don't want to see the horse. No. You don't want to see my drawing skills. Is that a nay? Yes, sir. With the side of hay. Oh, that horse was horrible. Oh, I'll be so ruined if I have to draw another horse. Oh my goodness. If I have to show you my drawing skills, guys, it's oh goodness. Picasso, I am not being a scientist. You get limited by Oh, okay. All right. We're gonna try and draw a horse. All right. We're gonna try and draw the horse here on stream. All right. So let's switch over to the main screen since you've asked very kindly. You've all asked very kindly to draw a horse. Okay. Let's try. I'm giving you no guarantees. All right, that the horse is going to work out because it's me we're talking about here. All right, so we can it's kind of got a long face like this. Yeah, this still be bad. I've hit my long face here. But it's got a mouth that kind of looks like this. We have a body. You know, got like four legs. Oh, here's 2 legs here. And the tail. Here we go. Pictionary, not my thing here, but you know, here's it's got some brown fur here. Okay. Got to put some shadows here for the other 2 legs. So that's what I'm thinking here. Okay. But there we go. Gonna put the hooves here. Yeah. Why does this look worse than the first one? Oh my god. This looks worse than the first one. Oh no. God. Oh no. They're ears. Right, I forgot. There are ears. Right. Yeah. They're ears. The ears kind of look like this. Kind of look like. Yeah. Redemption failed. What is even? It's a horse. It's a horse. This is the extent of my drawing skills, ladies and gentlemen. Ladies and gentlemen, it reminds me of the weird yellow dog thing from Aqua Teen Hunger Force. But this is the extent of my drawing, ladies and gentlemen. The stick to math. Ouch. This was completely expected. You guys asked, I acquiesced, and you guys got this thing, whatever this thing is. Oh my gosh. Oh no, I've been ruined forever looking at that clip. Oh gosh. Totally ruined. That's true, Scream. Come on, we can all be airbenders together, Scream, okay? Okay. We're all Aang in our hearts. Alright? Or Korra, whichever one you like better. Oh my goodness. Ruined. Absolutely ruined. Oh my gosh. Alright. Okay. Let's get going here. We got work we gotta do. Regardless of what I think. We got work we have to do. Alright, so let's do some work. You could go back through the replay, Athena. Yeah, you could see the absolute abomination that was. Here, you know what? I'll just show this off here, Athena, real quick. There's my horse. Okay, that's what my horse looks like. It's pretty awful. There, now it's never coming back again. This never happened. Never. I saw nothing. Oh my God is right. I'm not going to argue with any of that. All right. All right, we got to do some real math here. All right, so let's do some intro. Let's get started here, and let's get on board with this stuff here. All right. Okay, let's get started today. Welcome back. Welcome back to Wednesday. End of the week time today. So for today, we're going to finish up section 5.1 and also finish up a section 5.2 here for today. So we'll get those two sections here done and dusted here today. All right, as a friendly reminder here, remember that section 5.2. Okay, remember that section 5, not section 5.2, chapter, the test here over chapters 1 through 3, pardon me. I'm thinking two things ahead at the same time. Chapters 1 through 3 test is due on Sunday at 11:59 p.m. Okay, so be sure to finish up the test by then. Also, all the homework is due on that same day, so be sure to finish up the homework there as well. All right, so again, if you haven't started yet, try the practice test first to get comfortable, and then once you feel that you're ready, go ahead and take the real test. And again, you got multiple attempts on the real test as well, so you should be just fine with the amount of time and questions and whatnot. So, I don't think that'll be too much of a problem here. All right. Anybody have any questions from last time? Any questions, by the way? Hey. Oh, this is gonna be one of those. Oh no. Ruined. Absolutely ruined. Oh, team Oink coming in. We got Team Horse and Team Oink today. Oh my goodness. All right. Good, good, good. All right. So today ay ay ay. All right. So today we're going to start talking off about uh today we're going to talk about here we're going to talk more about probability, what we talked about here in section 5.1. Last time where we left off here, we talked about sample spaces. Okay, we talked about exactly how to figure out certain probabilities. We know that all probabilities here are between 0 and 1 here, respectively. We talked about, again, you adding up those probabilities for each of those events. That is going to equal 1. All right, now today we're going to talk about a little bit more about how we can solve other types of probabilities. So let's take a look at number 6 here from the handout. Okay. Number 6 here says, how do we compute probabilities of equally likely outcomes? Let's go ahead and take a look at that here. How do you compute probabilities of equally likely outcomes? So it says, if an experiment has n equally likely outcomes, all right, and the number of ways that an event A can occur is m, the probability A, P of A, is equal to m over n. Okay, so that's one of the things here that we talked about here last time. Remember, one of the examples here is, for example, saying rolling a 5 on a 6-sided die. So we said, okay, there's an equal amount of chance that every number can appear on a 6-sided die. We roll it at random, and then we're like, okay, well, it could be anything from 1 to 6. Well, we know that rolling a 5 is a 1 out of 6 chance for showing up on the die, as much as rolling a 2, as much as rolling a 6, okay? They're equally likely outcomes at the end of the day. All right, hydrate. Ashley says hydrate. Okay, so today's drink, by the way, is very unusual, by the way. I'm just going to put that out here. We have a very unusual drink. I tried this in the first class. This drink is really outstanding. So this is a salty lychee. Okay, salty lychee, if you want that. This is juicy lychee and Okinawa sea salt, and this is for a refreshing drink for the heat, even though it's cold out there. But this stuff is really outstanding, like really, really good. So I ain't gonna lie, this is so good. I bought this for like $2-3, but I'm not gonna lie. That's actually really, really good. It's really, really good. So I bought this at Mitsuwa, like I buy most of my drinks. Hey, hey. Gotta go to Mitsuwa. That's where I get all my drinks from. Yeah, exactly. Bet indeed. Make a run out there. I highly, highly, highly encourage you to make a run out there, Ashley. All right. I spend like I spend like $40 on drinks. So if you want the good stuff, JD, you got to make the effort. That's all I got to say. Okay. Now, one of the things that we talked about here last time is we talked about wording in the wording in the question, okay? I want to go ahead and reiterate that here once again in chapter 5 and from here and beyond. Wording is going to be incredibly important, okay? Wording is going to be incredibly important from here on out for the rest of the book. I'm going to just point that out here right now. So, let's remind ourselves a little bit about said wording. So, if we take our good friend the six-sided die here once again. Okay. So let's say I take the probability of rolling, let's say, oh yeah, have your boyfriend drive you there. That sounds good. So what's the probability in this case here, everybody, of rolling a 1 or a 3? What's the probability here of rolling a 1 or a 3? Probability of rolling a 1 or a 3. What's that going to be? Well, Connor. One third, okay. How do we get that? How do we get that 1/3 there? 2 over 6, so 1 over 3. All right. All right. Okay, so that is correct. Okay, so there are two possibilities. Okay, we get a 1 or a 3 here. There are two numbers, 1 or 3, that can appear on the die. All right, out of 6 possibilities here. That's correct. 6 sides and only 2 ways to get those numbers. That's right. And then we can reduce that down to 1/3. Okay, so that's fair, right? Roll the die twice, magically get, you could either get a 1 or a 3. You have a 2 out of 6 chance of getting a 1 or a 3. Seems fair. Right? Absolutely 100% true. That's right, Connor. Correct. All right. So let's take a look at the other one here. What's the probability of 2 and 4? Ah, you did something good, buddy. The probability of 2 and 4. All right. The 2 out of 6 or is it 0? Let's see what other people think. Is it 2 out of 6 or is it 0? Okay, JD says 0. Anyone else? Okay, Julia says 2 out of 6 maybe. Okay, kind of on the fence. Fair, fair. Let's let's put a little. Okay, people are a little bit on the fence about this one. So let's see here. Put a little poll here. All right, let's put a quick minute poll here. All right, so vote up above. So probability of 2 and 4 is 0, or I just want to see where everybody kind of sits here. Okay, so looks everybody put here 0. Okay, good. Just want to be sure on the safe side here that everybody is, everybody's safe here. So, okay. The answer indeed is 0. That is correct. Okay, good. So again, the key words here, as we've talked about here, is or and. Okay, we did talk about this last time, but I want to give a refresh here about, okay, or and are two separate words here, and they have a very different things that we want to talk about. So again, uh, gotta be gotta be careful about the wording here. That's something that we're going to be on the prowl about for pretty much for the rest of the book. So we're going to see some wording here today, certainly, and we'll see some wording here in future sections. That's for certain. Okay. All right. Now let's talk about some other things here right away. Let's take a look at question 7. Question 7 says, what is the empirical method? We'll look at some, by the way, some examples here shortly. So, okay. So the empirical method is basically usually involves a large amount of trials in an experiment. So I give an example here. It says the example here is like flipping a coin to determine the probability of getting heads is more accurate the more flips you make. So think about it this way. If you take a coin and you flip it and you say, well, what are the odds I get heads? Well, technically, the odds of getting heads when you flip a coin is 50-50. Okay? It's one half, okay? There's one side of heads and one side of tails. All right? Now, the thing with the empirical method is in order to prove it's 50-50, flipping it once isn't going to be enough. You need to truly show that it is indeed 50-50, and to do that, we take many, many trials here. So even if you flip a coin 10 times, flipping a coin 10 times doesn't really tell you anything. Because in flipping a coin 10 times, you could get, say, 7 heads and 3 tails, in which case you have a 70% success rate of getting heads to show up on the coin. When in reality, with a fair coin, it should be 50-50. So instead of doing it, say, 10 times, maybe you do it 10,000 times. Okay? And so, in a lot of cases, what we need in order to showcase that indeed a probability does exist, or a solid probability for us to make proper conclusions, is we need a sufficiently large enough sample size to make that particular conclusion. So, flipping a coin here to show that 50-50, we would probably need at least 10,000 flips in order to actually highlight that we indeed have a 50-50 split between heads and tails. That would be a large enough sample size. Again, certain circumstances may require a smaller sample size here to show a sufficiently large enough sample size. Again, it's not just a set number here, but certain probability experiments can be easier than others. Okay, so if I want to look at a lot here, a lot of parts, or let's say bricks, okay, maybe a lot of maybe 150 bricks, maybe a good sample size for us to see if there happens to be issues with the quality of construction in the bricks. And we can see how many are defective or not. If we see a lot of them are defective, maybe we have some problems. So there are certainly things like that. Are there any questions about the empirical method? Again, this is used all the time, by the way, in pretty much every field that you can think of known to man, the empirical method. So you want to now with computers and stuff, you can take millions and millions of trials, and you can actually literally make things using the empirical method, make proper conclusions. Like sports uses it all the time. AI programming uses the empirical method all the time. Everything like that. Oink indeed. Boo indeed. Gonna devolve into chaos already. Yes. Oh, mercy me. Sweet mercy. All right. Alrighty. Good beans. Okay, so let's take a look at some more examples here from this section, and we're going to see how we can figure out some probabilities here, at least to start with. So let's take a good look at this, and let's see what we're... Yeah. Okay. Go to... Wait. What? Okay, let me read this again. Professor Chips had a farm. I-A-I-A-yo. Not E-I-E-I-O. I-A-I-O. A-A-O. This is... Oh my gosh. All right. I'm dead. I'm dead over here. Okay. Let's take a look. Let's take a look at an example. Oh my gosh. Die over here. All right. 240. All right. There we go. All right. Let's take a good look here at number 30. All right. Let's look at number. Why? Why have you done? All right. Number 30 here. If you sing in Spanish, no, I agree. I'm not gonna. No. I agree. If it's sung in Spanish that way, yeah, yo. There you go. All right, so let's look at number 30 here. A bag of 100 tulip bulbs purchased from a nursery contains 40 red tulip bulbs, 35 yellow tulip bulbs, pardon me, and 25 purple tulip bulbs. All right. Okay, let's look at letter A. What is the probability that a randomly selected tulip bulb is red? Okay. So the randomly selected tulip bulb is red. What do we get here for 30A? Probability that a randomly selected tulip bulb is red. Okay, anybody tell me the answer for this one here? Probability that the selected tulip bulb is red. Okay. All right, 40 out of 100. Okay, so again, give me a decimal here, by the way. So 40 out of 100 is correct. I agree with this. So 40 out of 100. Or again, our decimal here. Let's get our decimal answer. So I guess I should have said that before. We want a decimal answer here. Again, just as a friendly reminder here for you guys, 4. 40 out of 100 is 4? Oh, no. No, Alyssa. Make sure you got that point 4 there. I think you missed the point part there, Alyssa. Be very careful about that. So one of the things I am going to stress on here is that Remember that for all decimal answers here, really quick, give yourselves a reminder here. All decimal answers are out to 4 decimal places. Okay, so remember that's going to be our standard practice here for this course. Okay, pretty much a lot of the questions are going to ask you to 4 decimal places. If you need, you need to put the zeros, of course, on the ends, but like 0.4 is fine. But if we get like, again, kind of weirder decimals here, we're going to still take it out to 4 decimal places, as that's usually the MO for what they want here for later things. So um, 0.4 is correct though. So we have 40 red tulips out of 100 total tulips in the bag. So we're good to go. All right. What's the probability of purple? What's the probability of purple? How about that second one there? But the probability of purple. 0.25. Okay, how do we get that? Real quick. So I want to see the fraction here first, and then give me the decimal there. So 0.25 is correct. I don't disagree with that. 25 over 100. Okay, good. All right, so 0.25 is spot on. All right, good stuff. Now this isn't hard. Okay, not hard. Okay, it's again fairly straightforward here. Again, it's not intended to be super duper difficult. So, a couple of things that I want to discuss here is that, again, you set up the fraction here so that way you have the number of possibilities, in this case for a purple bulb to come out of the bag, which is 25 of them, out of the total number in the bag, which is 100. Okay, so, and then we got 0.25 here, no problem. So we randomly just reach in the bag, we have a 25% chance, for example, of selecting a purple bulb for whatever reason. Okay, seems fair. Okay, now that's not too hard here. Now let's take a look here at another problem though. Okay, so we're going to look at 35 here. All right, so let's look at 35. Okay, so college survey here. In a national survey conducted by the Centers for Disease Control to determine college students' health risk behaviors, college students were asked, how often do you wear a seatbelt when riding in a car driven by someone else? So the frequencies appear here. Okay, so it goes from never to always. Again, to remain safe, please wear your seatbelt. That'd be a great idea. Um, but let's go ahead and I'm going to ask a few questions here. Not from the book here necessarily, but let's go ahead and answer at least a couple of questions. First and foremost here, what's the probability of most of the time? So if we randomly selected a person here, what's the probability that they wore a seatbelt most of the time? What would we get there? That's our first question here. Probability of most of the time. Okay. 1257 out of 4,776. Okay, I like that very much. That is something I can get behind here. So we have 1,257, which is again the amount of people that had responded that they wear a seatbelt most of the time here in a car driven by someone else. And again, to get the 4776, just to reiterate here, which is also correct, all we did was take the sum of the frequencies here. So this is the sum of the frequencies. So just showing off here how we get these values here. Okay, and correct here. Okay, so remember, Julia here, we want 4 decimal places here, Julia. So 4 decimal places. All right, so be sure to remember 4 decimal places all the time. So just be a little bit careful about that, so uh, that way you catch yourself there. Okay. No worries about it, Julia. That's why. Look, I'm glad we're ironing out the wrinkles earlier, because if you did it later, then you'd have more problems. So, I look. I'm gonna be fully honest with you guys, and again, it's okay to make mistakes. I'm here to help you with your mistakes. Okay, if you make a mistake, it's not like I'm hating on you. I just want to smooth out those wrinkles so you get a better grade down the line. Okay, so um, and get better results. So that's what we're aiming for. So don't worry, don't feel afraid about making mistakes in front of me. I've made plenty, too many to actually count. Way too many to actually count. I can't tell you how many mistakes I've made, but there are more. They're pretty bad. That horse was a mistake. You got that right. Yeah. Sometimes so the homework usually has you round to 2 decimal places. Some of the homework is gonna have you round to 4 decimal places from here on out. To be fair, that's why I'm being very careful, because some of the homework problems will definitely go to 4 decimal places, and some of them may go to less. So that's why I'm going to 4 here to kind of cover the base. To be fair, there, Athena, that's why I'm kind of just be like, make sure you put it in the correct format that my math lab wants, but you can easily go from 4 to 2 without too much trouble. So, and if you need to put it into 4, you have it in 4. All right. Yeah. So, Gene didn't even do nothing. Oh my goodness. Okay. All right. uh, homework is weird. Yeah, homework is weird. Homework is weird. I ain't gonna lie. Homework is real. So, all right. So here we get 0.2632, and that's the correct answer for that. All right. Let's do one more here from this particular question. All right. Like I said, I'm here. I'm here to fix anything that needs fixing. So we're adapting as we go along. All right. And how about the? All right. So all right. So the probability. So I'm going to put it here. Probability of never or rarely. What's the probability of never or rarely according to the chart? $449 over 747.76. This is correct. Okay. And what do we get here in this case? All right, so we get point 0.094. Okay, good. Perfect. All right. That is correct. 0.0940 is spot on. Very nice. All right. Okay. Any questions about that? All right. Good beans. Okay. Any questions so far? No, sir. All right. If I had said never and rarely, it would be 0, as you can't be both never and rarely. Never or rarely means one or the other or both. But never and rarely just means both at the same time simultaneously. So the answer to that, Athena, would be the same thing as like the probability of rolling a 2 and 4 on a 6-sided die. It'd be 0. You can't be in two categories at the same time. So unless the events are made that way, which we'll talk about here momentarily, Athena, it'd still be 0 in this instance. Yeah, we're going to talk about that actually right now. So glad you asked that question though, because it's a very fair question. And let's showcase exactly the latter half of that question Athena asked right now. Okay, so we're going to talk about here next is the section 5.2. Section 5.2 talks about compound events. Okay, so first of all, let's talk about what a compound event is. So a compound event is where two or more events occur. Okay, so two or more events can occur. That's basically a compound event. Now, what can happen between two or more events is that they can fall underneath one of two categories. Okay, and what are those categories here? Well, the first category here is going to be what we call a mutually exclusive or disjoint events. So number 9 here says, what does mutually exclusive / disjoint mean? These are two or more events that have no outcomes in common. Now, you're probably saying, well, that's a little yeah, that's a little confusing. Okay, to be fair, I don't disagree with that. But let's look at an actual picture. Let's look at a pictorial representation, okay? So look at a picture representation of what this question actually represents. So sometimes a picture here says a lot more than maybe the words, and so this is definitely one of those guys. All right. So let's say here this is our big box. This is our big box here, okay? And within this big box, let's say this big box here that you can see is going to be our sample space. So this is our sample space S, our possibilities, right? Now, we have our first event here. Now, if they're mutually exclusive or disjoint, let's say this is our event A. You guys have probably seen a Venn diagram before, and this is very applicable here also for events, whether it be mutually exclusive or not. That's event A, circled in black, and this is event B. So A has a certain amount of things in the sample space, and B has a certain amount of things in the sample space, but notice that they are separated from each other. There is nothing in common between event A and event B. Okay, they're two completely separate things at the end of the day. Right? Nothing in common whatsoever. Right? So if we look at there carefully there, again, as we see, absolutely nothing in common. They don't overlap anywhere. So as we can see here on this next part, on the left-hand side of the screen, you can see we talk about what's called the general addition rule. If we conclude that basically A and B in a scenario are mutually exclusive, they have nothing to do with each other, then we could say the probability of A or B is equal to the probability of A plus the probability of B. However, we can run into an issue is what happens if they were not mutually exclusive. So what happens if they look like this? Take away the circle here. Maybe I make my blue circle this, where it is now over letter B. So now you see that there is an overlap between A and B, so these would not be mutually exclusive or disjoint events. So if they're not mutually exclusive, then we have to make one adjustment. That is, the probability of A or B is the probability of A plus the probability of B subtracted by the probability of A and B. Okay. And the reason why we have to subtract off the probability of A and B is because this takes away the double counting that you do of both A and B here. So if you take a look here, we count up A, everything in A, we count up everything in B, but this whole place in between, we actually counted 2 times when we counted up A and we counted up B. So we have to take away one of those countings there to actually find out what the probability is at the end of the day. All right. Now we've gone ahead and we went ahead and did that. Let's go ahead and take a look at some examples though. See what we're working with here. Let's see what we can do. Okay. Let's look at an example here. Work with it. Let's use real numbers here first. This is okay. So we're going to look at question 29 here on page 252. Our first example here. Okay, let's take a look here. So 29, Medicare fines. In an effort to reduce the number of hospital-acquired conditions, such as infections resulting from the hospital stay, Medicare officials score hospitals on a 10-point scale with a lower score representing a better patient track record. The federal government plans to reduce Medicare payments to those hospitals with the worst scores. The following data represents the scores received by Illinois hospitals. All right, and so here we see a bunch of hospitals here, right, with their respective frequencies and whatnot. All right, and we're going to answer some questions in relation to that. So let's look at letter A on the next column here. We'll go back to the table here in just a second, but let's look at A. Determine the probability that a randomly selected hospital in Illinois has a score between 5 and 5.9. All right. Let's start off with something nice and simple. So the probability between 5 and 5.9. So can anybody tell me here, based on what we see here on the table, what's that probability going to be? Okay, good, right? So simple enough here. 23 out of 125. All right, and we indeed get 0.184. Okay, 100% agree. All right, so that's not too hard, right? Everybody saw pretty easily, like, okay, there's 23 in that category. Fair. Out of 125, which is how many were polled here in this particular frequency distribution. And now we just go ahead and take a look here and see. No? All right. Well, you get 0.184. All right. Nice job, everybody. 100% correct. All right. Now, let's take a look at another question here. I'm going to skip over to C here. And it says, all right, so we want to find the probability that we want to determine the probability that a randomly selected hospital in Illinois has a score that is less than 9. So a probability that we have a score less than 9. Okay. Got 120 out of 125. All right. Okay, 0.96. Okay, good. Okay, very nice. Good job, everybody. Correct. Okay, now, what I want you to do here is I agree with everybody here. 120 out of 125 here. Absolutely spot on correct. 0.96, spot on correct. Tell me how you arrived at that answer. What I'm curious to know from everyone here is, how did you get to that answer here? What did you do? You guys describe to me what you did here to arrive at that 120 over 125. So you did 125 minus 5, okay? All right, that's fair, JD. What did other people do here? How did we arrive at that 120 here? What else? Or did people do the same thing as JD? I don't know. People have a different way of doing things, and that's why I'm asking this question here. Did some of you actually add all the numbers together there? Maybe you added up all the numbers between 1 and 8.9. Maybe some of you did that. It's possible. I'm not criticizing you. I'm just saying the different way of looking at things. This is if you added it together. So let's put another poll here. I think another, actually, probably should have had the first go around, but hey, right? You guys put your method there in the poll. So I have the poll up top. All right. There I have the poll up top there. Working smart, not harder. I mean, I ain't gonna lie. But everybody's got a different method of doing things, and I don't care which method you decided to do. I just want to be sure that so some people subtracted 125, and then other people could have added all of the frequencies together. I had a few people in the first class take all the frequencies, add them together, and that's perfectly valid too. So if you decided to do it that way, then you could mark that down as your method. All right. Okay. If you're not sure, that's okay. Okay. So the answer we got here was going to be so we got people took 125 minus 5. Okay. So there are going to be two ways to do this. First of all, it's exactly as I mentioned here. The other way is, again, just taking all the frequencies here. And if you went ahead and did that, that's perfectly fine. You take with 3 and 12, 16, 23, 23, 21, 17, and 5. You add those together, and you'll indeed get 120 here. This is especially true if you don't know the total here. So imagine if this total wasn't given to you down here, then maybe you would add those together and see what you got. So that's certainly a valid method there. And if you did decide to go down that route, perfectly okay. Now, there is another route here, and that is that 125 minus 5. Now, there is a significant representation of 125 minus 5 here, but maybe not in the way that you were thinking. So what we can do here is we can find out 0.96 in a different manner. And this is going to talk about the last question on the handout here. What we're going to be using here in this example is we're going to be using what's called a complement. Now, compliment is not saying something nice to me, though you can, and I'll be very grateful. I know you don't, because, well, I'm a math teacher, and I probably shouldn't. Anyway, what does a complement mean and the rule of complements? Complements in math language means not. Okay, so it literally means the word not in a math language, right? And we do have this notation here specifically for complements, which is A with a C here on the exponent, okay? Now, how does the rule of complements go? Well, it's going to be the probability of a complement, which is just A is just the event, by the way. So some event, the complement of that event, is going to equal 1 minus the probability of that event. So the opposite of that event, essentially. And you're probably thinking, where does that fit into this particular problem? Let's take a look here. We want to find the probability of less than 9. And it's as Athena said earlier, we want to work smarter, not harder. Okay, so if we want to try and take the path of least resistance, well, sometimes we need to change our perspective here just a little bit to make a lot more sense about how to actually approach some of these problems. So, the way we want to do that here specifically, in this instance, is I want to go ahead and say, okay, I want to find the probability of less than 9. Now I have to do is take the difference here. I take the complement of that, again, the opposite of less than 9. So if I'd use the formula here, and this is going to equal 1 minus, and we want to do the opposite here of less than 9 here. This was the probability of 9 or more. Okay. So we take the probability of 9 or more, because that's the opposite here of less than 9. All right. And so if we do that here, looking at our example in our book, the probability is going to be 1 minus 9 or more. And there's only 5 people within the 9 or more part here. We do 5 over 125, which then gets us back to 120 over 125. And that nets us our 0.96 that we had got from above. Now, this is really important here, at least for the rules of complements, because certain problems that we'll see here in this chapter and further on down the line, since we have to be really extra careful about wording, all right, especially about wording here, we have to be really careful about that. Well then, this is going to prove to be very, very helpful to take care of some of the wording when it could be really hard to add up a bunch of things together. Instead of adding up a bunch of things together, maybe it's okay to go the opposite route and just take stuff away. So some wording here is going to be a little bit more difficult to deal with. We don't have the complements floating around and hopefully making our work a little bit easier. Yes, Athena. Yes. wording is going to be wording is going to be very important. As I mentioned here, it's the kind of the make or break thing about probabilities is you have to be very careful about how things are phrased. So, devils is always in the details. Are there any questions about how we found that both ways? Any questions? A move. There we go. Okay. All right, let's take a look at another example here. All right, so let's look at another example and we'll see how it works. Right? This time, it's something that we'll talk about here at the end of the semester, but this is something that we can work with right now. So at least let's work with it just a little bit. And that is something that we call contingency tables. I'm going to do number 40 here, and we're going to answer a few questions here regarding that. So let's go ahead and do that. Okay, number 40 here. Number 40 says, all right, so a guidance counselor at a middle school collected the following information regarding the employment status of married couples within his school's boundaries. All right, fair enough. So here we have work here. We have a husband, we got a husband works, wife works only, or both spouses work. All right, and then the number of children that are under 18. And so here we have 0, 1, or 2 or more. And we have the totals here, respectively. Okay, so the first one I'm going to work with is that let's just go off with something simple here to start with. Okay, so let's look at letter A. So it says, what is the probability that for a married couple selected at random, both spouses work? So the probability that both of them work. Okay. All right, so let's take a look here. What's the probability according to the table here that you see right below my face? What is the probability that uh, both parents work? So 5,000%, hello. I see. Not according to this table, sadly. Uh, we're in college statistics here. Hello. Let's see here. 1149 out of 1700. Okay. All right. So 1149 out of 1700 is correct. We polled 1700 people for this survey. That's what we see here in the total. And then we say, okay, how many of them were underneath the category of both of them working? Well, in total, and this according to our row here, is 1149. Okay. And then Julia has our decimal equivalent here to be 0.6759. All right. Agreed, agreed, agreed. Nicely done. Cool. All right. That's correct, Planet. Very good. All right. Next. Let's take a good look here at letter C. So, yeah, kind of. All right. All right. So the letter C. What is the probability that for a married couple selected at random, the couple has 2 or more children under the age of 18 and both spouses work? So probably a 2 plus and both. Probably of 2 plus and both. All right. So how many people are underneath? We have 1,700 people that we surveyed. That part is going to stay the same. But what about what we see here for this? People are 2 plus in both here. 370 out of 1,700. 370. Right? All right. Good. That's right. So again here, let's take a look at what we see here. We want 2 plus and both, right? We want 2 plus and both. So we have 2 plus in both here. They have to have 2 or more kids, according to this column, and both of them have to work. So the amount of people who, out of the 1,700 we surveyed, 370 of them satisfy both conditions. And so completely agree with everyone here. Indeed get 370 here as a result. And Julia has put that up for us very kindly as 0.216. All right. So far, so good. Okay. Get letter D. What's the probability that for a married couple selected at random, the couple has no kids or only the husband works? The probability of 0 or husband. Okay, let's take a minute on that one to have you guys think through that one and see what you guys get. Probability of 0 or husband. I'll give you a minute or two to do this one though. This one's not so easy. That would be bad. Okay, better do that. That's kind of important. All right, so we got several answers here. For 25, 788. Okay. All right, so I'll just say this to both you, Planet and JD. You guys are a little bit off. So here's a hint. Here's a hint. Go back to the general multiplication rule, a general addition rule. Sorry, what am I doing? Back to the general addition rule. Okay, so just be a little careful about that. That is question number question here. So this is what you want to use. Okay. Question number 10 here on the handout. Should you guys give that another minute or so? I just want this to be a good challenge problem. So again, because I want you to have the correct perspective and mindset when you some of these problems. So okay. Got 1,041 over 1,700. All right. Now, what is that? What numbers do you use? Again, take a look at the table here. So the table that you see here. Again, you have 0 or husband. So we have 0, this column here with the total, and husband with this row here. So that's okay. That's why it's a challenge problem. Okay. It's intended to be challenging, so don't worry about if you get it wrong. It's about just getting your mindset in the right place. So okay, let's work with what we have here. Okay, so let's break this down one piece at a time. Okay, you're giving it some thought here. You're like, not sure where to go. I'm like, okay, that's fair. So, all right. Now, if we use the general addition rule here, let's go back for just a second. That says the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. So what we want to put here in this case is we want the probability of 0 plus the probability of the husband minus the probability of 0 and the husband. Okay? So the probability of 0 plus the probability of the husband minus the probability of 0 and the husband. So essentially, what we're doing here is we're going to add the number of people in the 0 category. We'll add that to the number of people in the husband category, according to our table here, which we'll look at in just a second, minus how many people are in both of those categories at the same time. Let's take a look here at let's take a look here and what that answer is going to be. According to our table here, let's, again, one step at a time here. The probability of people in 0, we have correctly stated earlier here, was 788. We have 788 people have 0 kids. Now, how many people were in the husband category? Well, if we look at that row there, the total there is 425. Okay? How many people are in both the 0 and the husband category? So so I'll ask this question here. How many people are in 0 and husband? $15, $13? No, 0 and husband, okay? $12, $13? $12, $13 is if we added this together here, but what I'm asking you here is the subtraction part. Now I'm asking you to subtract 0 and husband here. Okay, how many people are in 0 and husband? So according to this table here, number of people who are in 0 and husband is only this overlapping part here of 172. Okay? Remember, and husband, not or husband, and husband. Okay? We need to be extra careful about that. Okay? So we can see exactly right. Now this is why I'm going through this very carefully. Right. This is the most important part here of what we're talking about here today. 0 and husband. They overlap at 172. Now let's look at this even further. When we did the first part here, okay, so I can expand this just a bit. When we did the first part here, we said, okay, we did the probability is 0. So when we counted the 0 column, this is all the 0 column, right? This 0 column here. Okay, that we got the 788 from that. So we just added these up together and we got 788. We did the husband row here, and that's where we got the 425 from. Okay, no problem. But you see here, we added up to get 178. We added the 172 to get 788. And we added the 172 again to get the 425. So that's why we have to take away the double counting. We counted 172 2 times. So we need to take away one of those 172, and then we can take that out of the 1700 to finally get our final probability. Okay. So if we put it this way, then what Planet had put in earlier of 1041 is correct. So we get 1041 over 1700. And here we're going to get our final answer here of 0.61. Okay. That's correct. Very good. Nicely done, Athena. That's right. Are there any questions about that? I want to be sure that everybody's pretty crystal clear about our reasoning behind why we went ahead and did it kind of piece. Again, we just did it one piece at a time here. Okay, we did it one piece at a time here. Okay, but it's good that we see it one piece at a time, so you can see exactly how we came up with that conclusion, right? Okay. Well, I'm just hoping everybody's on the same page here. Okay, to be fair, I just want everybody to be on the same page. So, want to be sure that everybody's kind of got it down where it doesn't feel like it's super confusing. So, okay. All right, that's good. That's good. That's where the power of the general addition rule really comes into play, is when we're dealing with those ors there. I learned something today. Well, yeah. Watch me forget for the homework. Well, you can always reference back to this once you have once you forget. That's not a problem. All right. Let's take a look at the last one here. This is a reminder question, really. So hopefully we got that part down there, but let's look at letter E here. Would it be unusual to select a married couple at random in which only the wife works? So the probability of wife only. What's the probability for the wife, by the way? Uh, we can Discord chat about it. Yes, we can. Yes, we can. We'll be doing some activities with Discord here next class, so that'll be fun. Okay, and what's that equal to? Oh, that's okay, Julia. So we're doing letter E here. Would it be unusual to select a married couple at random for which only the wife works? So we're just trying to find the probability of the wife here, Julia. And we got 126 because that's how much, again, the wife works here. In this case, for this survey, out of the 1,700 that were polled. And we're just trying to figure out what the percentage is at this point. So we see here, what we get here, we get 0.0741 as stated there. Is this unusual, yes or no? That's really the question here. Is this unusual? Is this unusual? Yes, you say. Okay. Let's think back here. No, okay. Um, yes, you say. No, you say. Oh, maybe we need another poll. All right, let's do another poll. All right. Uh, unusual. It's either yes or no. It's just as simple as that. Do a quick poll here. I put null, but null works. Okay. So some people say unusual yes and no, or null with an L. That was my fault. All right. Vote in the chat right now. Unusual, yes or no? We got a 2-2 deadlock here. It's got about 20 more seconds to go. I'm gonna break this deadlock here. All right, looks like we got halvesies. Half people say yes and half people say no. Let's talk about the final answer here. Real. What? No. It like null? What does that mean? You mean nil. All right. Unusual is 0.05 or less. This is correct. So the answer here is indeed no. Okay, it is no. All right. So it is, that is true. So remember, one of the definitions we talked about a while ago that is now going to pop up a little bit more is that unusual was less than 0.05 or 5%. Okay? So, because we get 0.0741 here, all right, then this is not unusual. So we have a metric here about what unusual actually means, and it has to be less than 5%. Surprised Pikachu face. Yes. Yeah, so again, with the wife only, that's perfectly fine, okay? That's not unusual in the grand scheme of things. All right, any questions about that? Sure, we got that. Yes. Yes, I did it. Trying to think if I needed to do. I know there's awkward silence. I was thinking if I had to do anything else today. Sorry. I get lost in thought for just a moment. I'm just like, oh, I gotta kind of look ahead a little bit. So I'm trying to think if I have things I have to do. So sorry about that. Okay. Very good. All right, so this is where we're going to end off here for today. Now, I just want to let you know for next time, we're going to do a little bit of group activities here on Discord. So we're going to have that here for the next go around. So we'll be prepared for that. It's just some simple questions, of course, but should have a little bit of fun here together. All right, so the test is due Sunday. Yes. Yes, Julia. The test is due at 11:59 p.m. on Sunday. Okay, so do the practice test first. You'll get comfortable about what the real test is about since it's the exact test without the same numbers, even in the same order. And then, yeah, you can give the test a try. You get 3 attempts on that, and then there you go. Just get it done by Sunday night. So, best score wins. So, give you plenty of time since last Wednesday. So, you should be able to get caught up. No problem. Homework is also due that same day, by the way, so be sure to get it done by then. All right. Wonderful work, everybody. All right. Standard or central? Wait, that doesn't even make sense. What does standard even mean? What? What? What do you mean? Oh no. All right. Okay, guys, so I'm going to take some questions here after this class. So if you want to stick around and ask some questions, you can ask some questions here. I do have office hours now. The time zone, standard time zone, central standard time zone, you know that. Come on, planet. I'm not in England, which is Greenwich Mean Time, so that's GMT. All right. Thank you very much, ladies and gentlemen. Thank you very much, ladies and gentlemen. If you want to stick around to answer some questions here for homework and whatnot, I will be here for office hours here today. I am here just for you. In the meantime, though, yes, I did, Athena. That was the first thing I did. 100%. 100%. Had to go over that. I knew that was the first thing that was going to come up, and I'm like, that's the first thing that needs to get done. So, yeah, I got to be fair for every class. That's one thing I do promote. If I do in one class, I do the same thing here in this class. Because, in terms of material and whatnot. So, because I want everybody to have the same kind of academic experience. So, now for the other shenanigans, that's different. Just going to be honest with you. All right, Planet, you have yourself a great weekend. All right, we will see you on Monday. Muy bueno indeed, of course. Have a day. I try and treat everybody as equally as possible, trust me. You meet me in person, I'll treat you as equals. I told you I'm not necessarily a professor and student. It's just two equals. Two people just, I'm a facilitator of information, and I'll treat you like my equal until you give me a reason not to. Just have a day. Good good bad, just have a day. JD, I have a great day with you, my friend. There's no question about that. You guys are what makes this. You guys are what makes this amazing. This job amazing. So I can say it with definitive confidence that all of you are wonderful people, and you make every day matter because of just you being here. So I really appreciate that very much. Positive vibes. Got that right. You got that right, Athena. You try to recreate the JD. Don't do it. Don't do it, my friend. Please, please. You're gonna torture yourself. Just don't. Gosh, no, please. Okay. All right, you guys, have yourself a wonderful day. If you're sticking around, I'm gonna answer some questions right now. All right, let's do this. I do have my Twitter. Yes, I do have my Twitter. This is true. You guys feel free to. I do have a Twitter. You guys can send it to if you want. It's right there. I always forget I have a Twitter, but it's. But a lot of people follow my Twitter, so that's fine. They'll see the ridiculousness. Fair enough. Absolutely. You're more than welcome to post it on my Twitter. No question. Screenshot of it. Oh my gosh. 41-year-old makes a picture of a horse. Okay. 5-year-olds do it a whole lot better than he does. Like, yup. All right. Need question help with question 9 on section 3.2. Okay, you got it, my friend. I have full expectation you'll redeem me with your skills that pay your bills. Horsey challenge. Oh, hang on a second. Sorry. Looks like I just need to re-authenticate. Alright, there we go. Alright. Sorry, I just had to re-log in there. There we go. Alright, so 3, 2, and number 9. Okay. If it's a good drawing, I get ramen. Fair. 100%. I will certainly do that. Okay. So the following data represents the weight in grams of a random sample of 50 candles. All right. You guys can send me drinks. That's fine. Or ask me to get a drink and just tell me where to get it. I'll go get it. So, all right. So we have to determine the sample standard deviation weight. Okay. So, Painter, what I would like you to do here, my friend, is do it via the calculator. No. This does not have to... No. Okay, so Feiner, this doesn't have to be in numerical order, okay? Let the calculator do that for you in its stead, okay? There are 50 numbers here. I have no expectation for you to put this in numerical order, okay? The calculator will do that for you in its stead, all right? But we don't care about ordering here because all we care about for this part of the problem, at least, is we only care about the sample standard deviation, at least for this part here. So let's put it on the calculator here, all right? So I'm going to enter in all these numbers I see here. And I'm just going to do this off screen here. So, but I'm just going into the lists and, you know, just deleting it out, just clearing it out and whatnot. So, yes, it just, for Excel though, for Excel, the only issue with Excel is it's not, you can get the standard deviation. It's just, again, you have to keep bringing up different functions for each one. Especially if you want like some of the other things, it's faster via the calculator. You don't have to keep calling up functions. You can do it on one function instead. So there's pros and cons for using Excel. Just be careful when you're entering stuff in, Feiner. Just because there's a large amount of numbers. So just go, one thing I highly suggest, Feiner, is just to go slow. Okay, just go slow over each batch of the numbers so you have them entered in right. Kind of like entering in numbers is basically your war of attrition with this problem, so... .96 or 0.76. Okay. All right, so I've entered in all 50 numbers here according to this problem in the calculator. So here are, again, if you want to take a look at that, that's what all 50 numbers kind of look like there in the calculator there, Feiner. All right. So what we're going to do here next is we're going to go ahead and quit out of this. We'll hit second in mode to quit. We're going to go ahead and hit the stat key here. We're going to go over to calc. We're going to go to 1var stats here. Okay. Make sure that our list here is L1. Again, 1var stats L1. Remember to get L1 to show up on your calculator here if you have the old school calculator. Second in 1. Okay, to get L1 to show up. We're going to go over to calculate. And for this problem here, for the numbers that I have, this is what appears on my screen. Now, the only number that we care about here is this one right here, SX. SX here is our sample standard deviation, okay? So if we take a look at that here, okay, cool. So SX is the only one that matters. Now, you may have different numbers for your example there, okay? Thanks, Yusuf. SX may be the only one that matters for this particular part here. So here we get 0.0674 is what we get here for this particular problem. So let's put that down. I think, oh, but they want 2 decimal places, so we'll put 0.07 since that's what they want. Oh. There we go. Some reason it wouldn't put stuff in. Let's check that. All right, so that worked out just fine. All right. All right, so let's go through this carefully. Any questions, Feiner, so far? No? Okay, perfect. Let's move to the second part here then. So the second part is, on the basis of the histogram on the right, comment on the appropriateness using the empirical rule to make any general statements. So the histogram is not bell-shaped, or it is bell-shaped. Well, it's pretty much close, and it's pretty... Now, I know you don't have the same numbers. But, obviously I can't see the same numbers that you have. But I'm just showing you how you would go through this problem here. Okay. Yeah, that's the point. You can apply this here. All right. So B here says, basically, is the histogram bell-shaped or not bell-shaped? So remember what bell-shaped means. Bell-shaped means essentially this, right? This is what our normal distribution look like here. Kind of looks like this. All right. Now, if the shape of this histogram is close to what this bell-shaped curve looks like, if you put a curve on it, then this is what we would call a normal distribution. Okay? So, would I think that this particular shape is bell-shaped? I would say it's pretty close. It doesn't have to be exactly bell-shaped there, Feiner, but it has to be pretty close to it to be like saying, okay, it's pretty close to a bell-shaped curve, so I could say, all right, the empirical rule can be used in this particular circumstance. And in this case here, that would be correct, as long as it holds that bell-shaped curve there. Any questions so far about that? No. Okay. Good. All right. So let's look at this. Let's look at letter C here. Use the empirical rule to determine the percentage of candles with weights between 0.7 and 0.98 grams. Okay, so this is going back to remember our rule there? All right, so this one here is the 68, 95, 99.7 rule. Remember that rule that we talked about there? That was with our normal distribution and stuff like that, and we looked at the number of standard deviations and whatnot. That's what this question is talking about here, okay? So we have a mean here of 0.84, and we have a standard deviation of 0.07. Okay, so let's draw the picture out here for just a moment, okay? So 0.84 is kind of right here. Our standard deviation here is 0.07. So if we go 1 to the right, that's going to be 0.91. Go 2, that's going to be 0.98. Go 1 to the left here, that's 0.84 minus 7, that's 77. Yeah, that's 77. And then this is 7D. We could go further here. This is 0.63, although this is not necessary. But still. Did you have the picture of those percentages there? Those percentages are fairly helpful. In this instance, we want to figure out between, let's see what values here. Let's take a look. I'm going to shrink this down a bit. So we want between 0.7 and 0.98. So 0.7 is right here. 0.98 is right here. So we're going to add up all the percentages in between this line and this line right here. So the percentages we have here, 34, 34, 13 and a half, 13 and a half. If I need the other percentages, I'll fill them in. But remember, so I'll ask this here. We know that it's 34% because it's 68. Remember, the rule goes 68% is within one standard deviation of the mean. And because for a normal distribution, it's symmetric, we cut 68 in half. Therefore, I know it's 34 on the left and 34 on the right because of symmetry. It'll cut itself in half as a result. Okay. So all you have to do is look at the lines here. So in this case, we take 13 and a half, 34, 34. 13.5 is going to be, where is it? 98 minus, 97, sorry. Yeah, 97 minus 68. Or 95 minus 68, sorry. And then we divide that by 2. There we go. So we get 13 and a half and 13 and a half there. That's how we get the two 13 and a halves there. Okay. So in this case here, if we add up all these guys together, we're actually going to get 95%. All right. Any questions about that part? Okay. Now this next one here, this next part here, letter D. Letter D is basically a physical inspection problem. So you're going to look at all the data points. Okay, that's fine. Absolutely, my friend. Please take your time. That's okay. Let me know when you're ready for the next part there, okay, Feiner? Okay. I can wait for you once you're ready. Do what you need to do. No problem. Take your time, my friend. Okay, cool. All right. Let's move on to the next one here, Feiner. All right. So the next one here is going to be letter part D here. It says determine the actual percentage of candies that weigh between 0.07 and 0.98 grams on my thing. Yours is going to be different numbers, of course. But this is just a visual inspection problem. You're just going to look at the actual data set here. All right, so we're just going to actually look at the data set, and we're going to find out how many of these candies are exactly between 0.7 and 0.98 grams, including both of those values. And this one here is actually pretty easy to do because all you need to do is actually, because most of the values are actually between, in this case, between 0.7 and 0.98, including those two. So just look for the ones that are not in those, and then you'll be just fine. So let's take a look here. We have one value that's outside of that range. That's the 0.99. Oh, those are all in there. Those are all in there. Those are all in there. That's in there. So it looks like one value is actually outside of this 0.7 to 0.98. So one value out of 50 are not one value out of 50 is not in the range, so that means everything else is in the range. So meaning to say we'll have 49 out of 50 here that actually work. So 49 out of 50 here is 98%. And we got it. So I'll let you do your inspection of your data set. And let's see, hopefully you got that. But that one's just strictly based on the inspection of the data set. Okay. Remember, they're inclusive, so just be sure to include the, like, I had to include 0.7 and 0.98. Don't forget to include those, whatever your values are in your data set. Those are in your range. You just have to find the ones that are out of your range. That's all. Oh my god. And me. Alright. That's too funny. Too funny. I laughed at myself. Okay. Next, the last part here, last part of this question here. Use the empirical rule to determine the percentage of candies that weigh more than 0.91 grams. Okay, so this just goes back to our picture. This picture here with the bell curve. 0.91% is here. 0.91, sorry, not percent. 0.91 grams was right here, this line right here. So we're just going to add everything that's say more than 0.91 grams. So we're going to add everything here to the right. So we're going to take 13.5. So this percentage, and this percentage. Remember, everything from 0.9 to the right. So we're just going to add these things together. 13.5 plus 2.35 plus 0.15. And so my answer for this one, it'll be 16%. So let's see what happens. And I got it right. Okay. Oh, we got one more part there, but I'll wait for you first. Thought that was the last part, but we'll get that. Yes, that's correct, Fainer. These percentages I put here, Fainer, are set in stone. These don't change in a normal distribution. Just to let you know, they're set in stone automatically. So these percentages are not going to change. Okay, let's look at the last one here. Yeah, that's the last part here. Determine the actual percentage of candies that weigh more than 0.91 grams. Okay, be careful about this one here, okay? Be careful about my example you see here, okay? I want to point one thing out here, very important, and this will be important for your problem too. It says weighs more than 0.91 grams, okay? 0.91 is not included. Okay, be careful. So whatever your number is, if it's less than, it's going to be, again, not including that number, okay? So let's see, more than 0.91. Let's see how many numbers I got out of 50. Not this, not this, not this, not this. This is 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 out of 50, according to what I have. So I have 8 out of 50. Hello, Connor. Welcome back from the land of Valheim addictions. It's great to see you again. So this is also 16%. It actually matches up. It's pretty nice. Let's check. Yep. All right. Cool stuff. Is James still going crazy? Does he have red around his eyes and everything? Yeah. I'm answering questions here, Young. Some homework questions. So, yeah, that takes priority over everything else. Got it? Nice, dude. I hope that answers your question there, my friend. I know that one's a little bit tough, but I'm glad we got through it. Next one is tough too. Go for it, my friend. We're here to answer questions. Milk is spamming hints in the chat. I can see that happening. Go ahead, Fader. What's the next one on the list there? You mean number 10? Okay, okay. Sorry, when you say next question, I'm thinking, oh, okay, separate section, another question. All right, let's take a gander. All right. So the mean of the commute time for a resident of a certain city is 28.8 minutes. Assume that the standard deviation commute time is 7.6 minutes to complete part A through C. Okay. What is the minimum percentage of commuters in a city? What is the minimum percentage of commuters in the city that has a commute time within 2 standard deviations of the mean? Okay. So okay. I'm just checking one thing here. Okay. Oh, okay. Okay. All right. So let's take a good look at this. I actually want you to take a look at this one. I want you to look at what it says it's incorrect by. In this case here, we're not assuming, yeah, all right. We are not assuming a normal distribution. Just a general one. So we will use Chebyshev's inequality. So you remember that formula that we had up there? 1 minus 1 over k squared? That's essentially what we're doing here in this instance. So we do 1 minus 1 over 2 squared. All right, you know what? Put that stupid there. Yes, let's put it there. Because smartness is, I do smart things. It goes smart. So here I'm going to get 1 minus a fourth, which equals 0.75. or 75%? So I'll put 75% here. All right, got it. You put that there. What is the minimum percentage of commuters? Okay, for 1.5 standard deviations of the mean. Okay. So we're just going to do the same thing here. Go for it, my friend. I think we're just going to rinse and repeat this process here. So, yep. Okay. Good vibes today. Good vibes. We'll talk about this next part here once you got the first couple parts. So, as you can see here on the screen where I'm at. So, oh my goodness, it's Fobs. How you doing, buddy? Fobs, what's going on, my friend? Welcome to a mathematics stream. I'm answering some mathematics questions, but dude, thank you so much for the follow. It's really super kind of you. And Fobs, I hope you're doing really, really well, buddy. I hope you're doing really, really well. I hope things are going great on your end. I watched your stream there the other day. Oh no, man. No, I want to thank you for stopping in by, and man, I listened to you sing. You are absolutely outstanding. I was talking to one of your mods, and it was, man, you did a wonderful job. One thing I will say to you, Fobs, is that I really feel the passion in. I can really feel the passion you're singing there, and how much and wanting to do more. I can really feel that there's a lot of heart in that, and I'm really happy that you feel that you're in a better place after all that stuff. So, I mean, I'm really happy that you're doing what you love and that you're having a lot of fun doing it. So, really appreciate you, Fobs. Thank you so much, my friend. Dad loves you. Thanks, buddy. If you ever need to talk anytime, Fobs, come on by. You can talk to me at any time, man. I have no problems if you just want to sit and chill and talk, man. Anytime. I'm here to help. I'm here for a lending ear. Yeah. That's all I want at the end of the day, is to people to be better. Be a better version of themselves. Because I know it's there. Sometimes those roads take longer than others, but we all hopefully make it there eventually. So, as a teacher, that's my ultimate goal. To have people be better. And hopefully even be better than me. So, and if they do that, I've done my job. And I'll be happier for it. How would you plug in the second one into the calculator, especially? Okay, so for this one here, what we have to do is do the z-score thing. Okay, so what you have to do is you have to do basically this. I'll put it in the calculator for you here. So this basically is like the z-score thing that we've talked about before. Yeah, actually, I'm going to switch over to the main no face cam, so you don't see my ugly face. So basically, you're going to take 28.8. You're going to subtract it by 1.5 times what do we have here? What's our standard deviation? 7.6. Okay. So we get 17.4. And here we get 28.8 plus 1.5 times 7.6, and that's 40.2. And there we go. That's how we can do 1.5s on both sides, my friend. Hey, Athena, we'll talk to you later. You have yourself a wonderful weekend. You stay safe, stay healthy, and most importantly, Athena, stay sane. Very important. I'll check that. And there it is. Woo, yes. A 4 or 3. 8. 1.8, so that should be 7. No, that should be 6, because it's 22.8. Yeah, it's 22.8, so that should be 3. Okay, yeah, that's right. Okay. Got 3. Ha ha ha. 3 in my head. Let me know when you got that, Fainer. I'll switch to my main thing with my face back again. Oh, look at this shaved face. Semi-shaved now. Why are we multiplying 7.6? Because that is, in my case, that's the standard deviation that was given to me. Yours is going to be different. So whatever this is, it's the 7.6 is my standard deviation. Yeah. That's right, that's right. Fader, you should read what you wrote again. Yeah, you should read what you wrote again, my friend. My gosh. Oh dear. I know what you meant, man. I know what you meant, man. Oh my goodness. Just a smidge, just a smidge, you know. Oh, I know. I just found it hilarious, man. Hey, CNB, we're just answering some questions here for stats. I did teach class a little bit earlier, and I'll be having a class here in roughly 3.5 hours again, but for another stats class. Statistics, yes. Gotta love stats. Gotta love teaching. Period. Yeah, I hope it's straight fire, my dude. You love calculus the most? Respect, my friend, respect. I've been done like Calc 2 and beyond for such a long time now. I'll be honest with you, because I've been teaching pretty much from calculus and below. But I respect people who can do the calculus and love it. Calc 1 I can do pretty easily. Same with business calc, that's pretty simple. But for what I've been through, but yeah, Calc 2 was really rough. Calc 3 wasn't so bad, but Calc 2 was really rough. Let me know when you're ready there, Fainer. Yeah, so basically do 28.3. Just do what I have on the screen here. Just 28.3 minus 1.5 times 8.1. And then you have to do 28.3 plus 1.5 times 8.1. Go ahead and enter those in, and those are going to be your two answers there. All you have to do is just change that up. That's just using the z-score stuff, so... No, don't subtract 1.5 first. No. Do 1.5. So do 1.5 times 8.1 first. Order of operations there, Fainer. 1.5 times 8.1 first, and then take 28.3 subtracted by that value. Remember, parentheses are kind of a big deal, so if you need to put parentheses like so on your calculator, like so. Okay? Sorry, with a parenthesis at the end of that. My bad. Sorry, bro. Gotta bring it back, bro. That's how it has to work. Don't worry, though. That's what I'm here to remind you of. I got you. Alright, let me know once you got that stuff there. Your two answers should be pretty easy, though, once you got that. Alright, those are your two answers there, Fainer. That's what you should got. Alright, cool. Alright, last part here. What is the minimum percentage of commuters who have commute times between 6 minutes and 51.6 minutes? Alright, so the trick to this one is pretty easy. All you need to do is to go ahead and find out how many standard deviations that you have between one of the sides of these guys, because it'll be the same. So if you need to find out the standard deviations, let's take 6 minutes here, for example. We have a standard deviation here. In your case, you probably have, what, like 3? or something to that effect, like 4 or 3. Whatever the case may be. In any case, we're going to take 28.8 in my case, and we're going to subtract it by here 7.6x, and that somehow is going to equal 6. All right. So we're just going to go ahead and use the z-score formula. We're going to figure out how many standard deviations 6 is away from the mean by setting up this formula here. I'm just going to subtract by 28.8. So here I'm going to get negative 7.6x equals, and then I'll just do that on the calculator real quick. All right, so here I get minus 22.8 divided by negative 7.6. Okay, and so here we get 3. So we're 3 standard deviations away. All right. Because we have 3 standard deviations away, all we need to do specifically is use Chebyshev's inequality again. We're going to do 1 minus 1 over 3 squared. Okay. And we're going to end up with an answer here. All right. So we're going to get 1 minus 1/9. Let's see what happens. So here we get 0.889. Yeah. We get 88.9%. And we got it. No, stop. Go back. All right. And that should do it for that last part there. Fractions, you could just do it straight up, like 5, and then use the division key, and then like 5 divided by 7. You could just use that, or you could do the parentheses 5 over 7 like that. So just use the division key if you're doing fractions, my man. That's how you essentially do fractions. If you wanted to have it appear as a fraction, yeah, you don't have to do anything like super special. If you wanted to appear as a fraction on your screen here, then you could just do like what I have up here. I could just do 5 over 7, hit the math key, go to number 1, which says fraction, and then it'll appear as a fraction if you want to convert whatever decimal into a fraction or something. But yeah, you could just be like, okay, I just want to do 8 minus, and then in parentheses 5 over 7, and then convert that into a fraction. Okay, and then there you go. You got an answer there, just like so. Just as an example there. Yeah, in this case, you don't even need an ABC function here. You just need to enter it in straight up. Graphing calculator will make quick work of that. All right. Hopefully you got that one as well. All right, cool. Do you have more questions? I'm here until my next class technically, but I do need to get something for lunch or dinner eventually. Okay. All right, that's fine. You know, I am going to be on tomorrow as well, so if you want to ask me some questions then, I'm going to have like a Matho97 stream, but if you need to ask me some questions, you know, then I'll take your questions there as well. So it's totally up to you and how you want to play it. So, but I'm here 5 p.m. to 8 p.m. But I'm here until 6 o'clock for my office hours technically. So like I said, if you want to ask now, that's fine, or if you want to ask tomorrow, that's cool. I don't have a problem with any of that. So I'm here to help as much as I can. So you got any more questions, my dude? Ask away if you have any more questions. That is. Wait, what? That's insane. Why have you done this to me? Oh my goodness. Alright. Yeah, so I'll be on here from 5 to 8 tomorrow. Wow. So nice. Ooh, boy. Alright, very good. Does anybody else have any other questions there in the chat? Any other questions? Otherwise, I'm gonna step away for some FUD. Alright. You just keep me safe. All right, if there's nobody else here, I want to thank everybody here for coming out here to the streams once again for Math 102. If you come up with a question before 6, oh yeah, you can just email me. That's fine. Yeah, email me if you like. That's fine, and I can come. I can always answer that. Sure. All right. You can always come out tomorrow, 5 to 8. That's perfectly fine as well. All right. I want to thank everybody here for coming out here to the stream for 102. Thank you. You guys are wonderful. I love you guys very much. All right, you guys make this. You guys make this an enjoyable experience. Thank you again. I'll be here for Math 120 at 6 o'clock. All right, so I'll be here for then. All right, so everyone, please take care of yourselves. All right, have yourself a wonderful, wonderful weekend if I don't see you. And we'll talk to you later. All right, take care, everybody. Have a great one. All right. Bye, everybody. Woo!